millisecond peak data rates, connection density of over 1 million devices per square kilometer, and centimeter-level precision positioning. Frequencies above 100 GHz will enable ultra-high data rate short-range networks. Precise time
starting the program. May I request all of you to take your seats? Ranjit, can we ask all the speakers to come in? We can start the session and close the door. Good morning, ladies and gentlemen. A warm welcome to the next vision of our Honorable Prime Minister, which is called 6G in India. So this is the first conference in India happening on 6G. And to start with, we are starting with a standardization discussion on 6G. 6G research and standardization roadmap for future. This session is chaired by Shri Professor Brijesh Lal, IIT Delhi. May I request please to come on stage, sir. Ladies and gentlemen, give a big hand to Professor Saab from IIT Delhi, who is going to chair this session. Then we have the industry expert, Shri Manoj Gurnani, Head Strategy and Technology, Nokia. Welcome, Gurnani sir. We have the expert from TEC, who has been talking a lot of standardization in IoT and other things. Ladies and gentlemen, let's put hands together and welcoming Shri Sushil Kumar, DDG TEC. Sir. The next speaker all the way has come from United Kingdom. My good friend, Mr. Pradeep Bhardwaj. Please join us on the stage. Pradeep. Hi, is coming. Okay. We have another speaker from Jio, who is Satish Jamgani, who will be joining online. Yes, Pradeep, please. I was welcoming you, please. Then we have a standardization and public policy expert from SESI. Ladies and gentlemen, put hand together to welcome Dinesh Chand Sharma. Thank you, Pradeep. Thank you, Dinesh. Over to Professor Saab for the session. Thank you.
Morning, everyone. Am I audible? All right. So good to see such a good participation early in the morning. I thank all the panelists for making time, people who are here in person, and Satish, who's joined us online. So we're going to talk about something very, very interesting, something that's been on our minds ever since the Prime Minister announced India's goals and India's move towards 6G. How are we going to address the 6G challenges? How are we going to move forward, participate? Today we have a very, very interesting panel. We have participants from the government, industry, people who straddle countries. So we can look at implications globally for what we do here in India. And there'll be some interesting questions that I am looking forward to asking them, and let's see what their take is on that. So before we begin and start talking about 6G, let us first understand from our panelists what they feel about the 5G, the progress that it's making, and about how it is setting the tone, or is it not able to do so for 6G and beyond. So I'll start from Sushil Kumar ji.
Yeah, thank you, Chair. And it's my pleasure and honor to be the part of this gathering. The 5G is one of the most innovative communication technology that will change the society and make the digital transformation a reality And 5G will provide the very high data rate, that is 10 Gbps per second peak data rate, and the main feature, ultra reliable low latency and massive machine type communication. And these features are not available in the earlier generation technology, that is 2G to 4G. And 5G has been designed mainly for the vertical industries. Nobody is going to have the 1 Gbps on the mobile phone, and these features will be used mainly for the vertical industries like Industry 4.0 for private industrial network, intelligent transport system, 3GPP CV2X specifications, they have already come, and massive machine type communication, the per square kilometer around 1 million devices will be connected, and which will be very useful for the smart homes and the smart cities. So such type of features can be used in the country, and what I feel, the return on investment for the telecom service providers will come only from the use cases. So we have to develop the use cases in the country, and as Honorable PM has already launched the 5G services, and these are being rolled out across the country by the telecom service provider, and we hope the countrywide coverage will be available on 5G. Regarding 6G, we will be having much more better features. Internet of Sensing will be one of the main use case. Then cobots will be there, and we will be having the latency in microseconds. And the lot of work is in progress in 3GPP as well as in ITU-R WP5D. And regarding terahertz spectrum, which will be required, and the 6G, 6 gigahertz spectrum, the study is in progress. And WRC, that is expected in this year, and then WRC 28 will be there. The spectrum may be freezed in WRC, which are the biggest events of the ITU. And regarding the standards, what I feel, in 2028, the standards may be freezed by 3GPP. Thank you.
Thank you very much. Always good. It's very reassuring to know that the government believes that 5G is on the right path and it will take us onwards towards 6G. So Manoj, what's your take on it? How bullish is the industry about all this?
I'm sure 5G is the most researched word on Google. I think 5G adoption has been pretty decent, I would say. Globally speaking, we have over 260 public networks. I think in terms of private networks, we have more than 1,000 networks. Nokia alone has more than 600 networks, out of which 125 odd will be 5G private networks. And historically, if you see, the adoption of 5G is actually better than 4G, because the milestone of 1 billion subscribers, 5G achieved 2 years before 4G, right? And if you look at the number of subscribers, last year we crossed 1 billion subscribers. End of this year will be 2 billion. So I think in terms of penetration, in another 5 years, we should be reaching 35 to 50%, depending upon the analyst's forecast. So the adoption has been pretty decent.
Thank you. So numbers have never really been a problem in India. What has been more challenging is the revenue. So if Satish has joined us already, would you want to comment on revenue streams? Are new revenue streams being established? Is it creating the right feelings in the industry as far as 6G is concerned? Satish?
Yeah, can you hear me?
Yes, we can. Please go ahead.
Yeah. So 5G has seen a massive investment across the globe. GSMA numbers state something close to about $1 trillion has been spent across the globe. But there's not one geography which has seen revenues coming back. So there are certain things one has to understand as far as 5G is concerned, the way it was designed. First of all, 5G was to a very great extent an extension of LTE. If you look at the airwave, it is more or less the same thing as LTE, but you have 100 megahertz, so obviously it was expected to give you much higher throughputs. But the biggest shift that 5G was supposed to show was enable B2B use cases, not B2C use cases. Operators were not supposed to be SIM sellers, but then supposed to be doing enterprise business as well to a very large extent. That hasn't happened so far. It still remains a B2C business. And why has the enterprise segment not necessarily taken off? There are a lot of other things. The nature of the architecture itself is one of them. For B2B business scenarios to be enabled, there are a lot of other considerations you will have to take into account. 5G is heavy, bulky, and when you get into enterprise, you're pitted with Wi-Fi 6, Wi-Fi 7, which is already endorsed by the industry, the critical so-called Industry 4.0 also. So, these are all some of the key challenges that one will have to look into. You're pitted against a technology where you get $100 access points. 5G is not necessarily the same thing. Spectrum is another key issue. A ton of issues. The one key issue people don't understand is also with respect to devices. Wi-Fi devices are quite nominal. It has already penetrated into all kinds of use cases, including IoT, including cameras, sensors. It's everywhere. But if you look at the 5G device ecosystem, for IoT, you need a different kind of devices. You have different classes of devices, category of devices. Now, the ironical part about 5G is there was no such thing called as 5G IoT at all. I mean, if you're a keen observer of the standardization process, much of what you call as 5G IoT is just extensions of the releases of LTE IoT, whatever you might call it. You still go to LTE, you still talk Cat1, you still talk Narrowband. Narrowband IoT is a extension of what was already happening. So it's more or less it's just plus of what was already available in LTE. So that's where we stand. So seriously, asking the question, what does 5G bring onto the table? And that's that's one key question that we ourselves have been asking. That also implies on the revenues. What does it look for the revenues? Fixed wireless is touted as one of the key revenue earners. There are other issues also, the device ecosystem. Again, you are pitted against fiber. If you go to fixed wireless, you have to be on par with whatever experience people are seeing with fiber. And there are still issues with respect to device ecosystem for such use cases. That's one of the reasons why you've not seen fixed wireless going everywhere. And also millimeter wave, massive MIMO issues, throughput issues, SANR issues, all these issues are there. So badly designed 5G, I was never happy about it. I've been vocal from day one, not today. Immediately as soon as release 15 came out, I knew this was disaster waiting to happen. So lessons to be learned, and at least 6G, we don't want vested interest to basically dominate standardization to make sure that, our voices are, we have clear views of what we want in 6G, and we are articulating that in ITU currently, and then subsequently in whatever other forums it has to be done. And that's where we stand. Thank you.
Thank you, Satish. So that's an important perspective. And 5G was a bit about putting the cart before the horse. We thought a lot of use cases would become possible, taking longer than we thought it would. So 6G offers an opportunity for us to consolidate, to do it right this time. Look at the use cases carefully and build the standard accordingly. Your thoughts on that, Pradeep? You will,
Yeah, good morning, everybody. Yes, I guess please bear in mind that when we say 5G is immensely successful, we talk about the number of operators that are live, 250 odd plus. We have to bear in mind that most of these networks are 5G non-standalone. 5G non-standalone itself was never meant to be called 5G in the first place. It was an afterthought for a lot of marketing reasons. The industry prevailed. There were two lobbies. There was a purist lobby, which only wanted the 5G standalone to be called the 5G. And the other lobby prevailed in Lisbon. And 5G non-standalone came to the fore to be known as 5G. But having said that, I'm not trying to undermine the success story of 5G. We have come a long way. The introduction of 5G new radio on its own represents a big uplift. And this is laying the foundation now for 5G standalone to make inroads. And we are already seeing that. Now that operators 60, 70, 80, I'm not keeping a close track of that. So these number of operators who have already launched standalone in their home networks, and I have started to play around with this wonderful 5G core. I think very soon we would see all of this unleashing huge benefits. So today 5G is all about consumer applications, mostly mobile broadband. We may talk about fixed wireless access and so on. But I think the proof of the pudding will be when the other industries, other verticals would start to adopt and embrace 5G. And when 5G standalone and 5G core starts to deliver on those benefits, that is when we can say now we have realized the dream that 5G promised to bring. And that is going to happen very soon. So in fact, I only came from the UK early hours, a few hours ago. And all of you must have heard about the coronation of the king that happened there on Saturday. It was such a delight to hear in the news that Vodafone UK, I don't work for Vodafone, by the way. So Vodafone UK actually deployed very successfully their 5G core network and deployed network slicing to allocate the 5G SA-based network slice to broadcasters for coronation. That is an exciting application, and it is actually solving a lot of problems in the marketplace, in the industry. So I think that is a very good example to start with as to how 5G standalone will bring these wonderful applications to the fore. And that is when I think we can see a mass proliferation of these applications and use cases into a lot of the other industry domains as well. So I think I would say we are on the right track, but there are a lot of challenges that remain unaddressed. I'll wrap it up shortly. There are a lot of challenges that remain unaddressed. So you would know that the baseline for 5G, which was released 3GPP release 15, that was defined way back in 2017, 2018. I have even forgotten, very, very long time ago, in California when the 3GPP meeting formally ratified release 15. Till today, we are into, past first quarter of 2023. And still we do not have the 5G roaming standards finalized. We are still having a dogfight in the industry about 5G roaming standards. Please bear in mind, we live in a global world today. It is not that we can get away with launching 5G just in our home network and assuming that subscribers and industries would not want this to be available to them in a roaming environment. It is all about roaming today. So I think these are the kind of challenges we have to address as an industry together.
Thank you. So it's important to bring out challenges at this stage, because when you set a roadmap for something, challenges is something that should be on top of your mind so that you address them rightly. So it's possibly a good thing that some of the points of views that we're getting here are not so positive. So of course, there's no reason to despair, because a lot of what we're hearing is positive. So Dinesh, quick few words from you before I move on to the next question, please.
So let me begin with Pradeep ji highlighted the technology has just started rolling out. I mean, of course, from an Indian context, we are late even in rolling it out. But then when you roll out and you start with NSA and go to NSA, the full potential of this technology is yet to be evolved. I mean, of course, we know the use cases, but when we implement those use cases, you learn from those use cases. Even if we have 229 commercial networks with more than 700 smartphone 5G phones, even with the predictions that the 5G rollout in terms of connections will become 2 billion by the end of 2025, there is a huge potential. And that's why we rolled out this technology. That's why we migrated from 4G to 5G. And there are use cases which will evolve, but then we just started. even if after 2 years. So it has few years of potential of its maturity in terms of rollout and capitalize on its potential and get the return on investment. So as far as commercial rollout is concerned, I still see that 6 to 8 years, this journey will continue. But then when we come to the 6G, and of course, even in 6G, even if the mission paper was launched recently, if you go back and see the research work all around the world, it started way back in 2 or 3 years before. But even then, I think we have launched this paper and we have a huge opportunity because at this stage, 6G is with vision and research. When you talk about standardization, I don't see that standardization will begin with the use cases before 2024 or 2025. But of course, it's market-driven case studies. So we are at the right time to do the research work, prepare the vision, and create the use cases. But for sure, when we will have the 6G commercial ready, the technologies like AI, machine learning, deep learning, and even blockchain will be fully integrated into that technology. That is what I can tell you today. We will not have softwareization. We will not have hardware installations. Probably everything is cloud, everything is internet. But then integration of these technologies will make 6G very, very efficient, which means we will have use cases where we will talk about it's not smart anymore. It's the intelligence which is lying in the network. Make use of the intelligence and make those use cases. And those use cases still we can foresee it, but then we will have that. So effectively, 5G rollout will continue, 6G research has to begin in parallel, and then we are timely on that. Thank you.
Thank you for those views. So research, IP generation, patents, all of that for the 6G point of view is becoming important. So here, I would like to go to the panelists and ask them that, research or IP generation requires a lot of cohesion, a lot of people coming together, academia, research organizations, the final industry that will take it to the market, people who will consume it, and also the government. So I'll come to Sushilji in the end here, because he probably have an opportunity then to answer some of the concerns others raise. So the question to the panelists now is, given that there are a few challenges, given that 6G is in a nascent stage, there is an opportunity for people and organizations to get together and make a difference. Where do you see India in terms of its ability to get all of the stakeholders in one place and make them work cohesively? So I'll start with Satish, if you can hear me. Satish, your views first, and then I'll take the other panelists' views.
So if I understand, your question was, where is 6G headed, right?
Oh, so I'm so sorry. Satish, what I said was that moving forward, we'll need a lot of cohesion between the stakeholders, academia, industries, large and small, consumers, government, all have to come together, put their heads together and try to come up with a mechanism so that we generate enough IP to make a significant contribution to the ecosystem and the 6G standardization process. So what are your thoughts on that, Satish?
Yeah, see, one of the things that has shifted in the recent past is the geopolitics of the telecommunication space. And that is huge. And that is huge, and that you will see it bearing across multiple set of activities. And we're already seeing that very evidently in the ITU activities. It is also becoming very clear that the so-called global harmonized standards, what is it worth? I mean, anyway, because one body trying to create a standardization for across the globe. If you've been to any of the 3GPP specification working groups, it's like 5,000 companies trying to negotiate something. And if you draw a mean of 5,000 ideas, what are you going to get? It's just one thought. So this whole business of this globally harmonized standardization itself has to be questioned, will be questioned in 6G. That's one of the key things that will happen. ITU, of course, is only trying to come out with the broader set of KPIs and the requirements. And then again, even in ITU, I mean, the traction that we see in ITU is okay. There was already IMT 2020 requirements, do plus plus. That is the scenario when we're looking at IMT 2030. It's a very sad scenario to be in. As I already told you, $1 trillion has been spent with no geography seeing any returns, at least till now, reasonable returns. And that is a very serious issue. $1 trillion in this economy is not a joke at all. And you go to standardization forums like this, and there are, I don't want to name companies, but you can take a guess. And they keep saying, okay, let's be conservative still, and we'll do plus plus of what is already happening. Come on. I mean, this is one of the key factors as far as I'm concerned, biggest concern from our side. This cannot be allowed to happen. And one of the key changes that we want to see happen is an opportunity for operators to move into B2B space than continue to be in a B2C space. It's not going to work out. Simply not going to work out. Nobody will see another $1 trillion investment if there is no clear return on investment. That is absolutely clear. And to that extent, whatever other subsequent terms that you used, IPs, research, and all that stuff, will all have to be aligned in this direction. B2B enablement has to be the biggest scene. And if there is push and pull from conservative industries, trying to, not necessarily innovate, but then try to do plus plus of what is already there in 5G, it's not going to work out. It has to move away from conventional thinking. That is one of the key emphasis. We will go in that direction. We will push in that direction. Thank you.
Thanks, Satish. So clearly there is a need for working together. And I'll start from the other side now. So Dinesh, what are your thoughts on that? And how can we make it happen more importantly?
Okay, so when I talk about research and IP relation, I see that in India, we have done a lot of research, but it did not see the light of the commercialization because it was not put forward on the right platform. And as you highlighted, when India awards these research projects, it goes to academias. The consortium is missing. Because when there is no consortium, when there is no stakeholders on board, who will implement that technology? Now, to implement that technology, the taker has to be there, which means it should be put forward on the right platform. Let's take a story of 5GI, but today 5GI became a 3GPP part of standardization. So we can see that some rollout could happen and may happen if the industry takes it. What I believe is that when the 6G vision is there in place, when we have fund allocation, government should do open call for tender for these research projects, not like awarding only to the IITs, because framing a consortium at a later stage is difficult. So they should launch call for tender and invite only consortium. I mean, of course, IIT could be a front-ending party, but then there should be a check criteria that you have framed a consortium and you're bidding for this project. With thought process in mind from a 6G vision, the consortium should bid all these different use cases which they believe will become a part of 6G. What is another thing which is missing is when we prepare a proposal and submit a proposal, we miss out the cost element which should be dedicated for standards and IP, which means you should have a resource since beginning of the research project who will take care and monitor these standards work all around the world, be a part of it, and then submit a proposal, have a roadmap, have an action plan, because when you start a research, you have to start preparations for a standardization as well. And then they should also participate in their SDOs. They should identify which particular standard organization I should be a partner to keep a track of it and submit my proposal as and when it is ready. So effectively, we should call it standard-based research project. There should be open call for tender. Without consortium, it should not be awarded. Then collect all these proposals, match the thought process of the government, and then award those contracts. And that is how it should work. So research, integration to standard, capturing the cost, then automatically it'll go to the IP. You see, what is the use of registering an IP if it is not commercialized? It will only commercialized when it is standardized, when it becomes a part of standard. So it should be put forward in 3GPP platforms to get it standardized. So this is what I think the few steps are missing. We can fix it when we are awarding it. Thank you.
Thank you so much. Though that's a very interesting point. So Pradeep, you just flew in from UK in the morning, and I believe you do spend a lot of time there. Anything that we can learn from other countries that we can correct here in India?
Yeah, I think first of all, we all can take collectively huge pride that we work in the mobile industry. When we talk about breakthrough enabling technologies, like electricity, that was obviously the invention of electricity was a breakthrough enabling technology. And likewise, mobile is the biggest one. We have made huge inroads. And one of the fundamental reasons mobile has become a breakthrough enabling technology is because we collaborate, we co-create, we collaborate, we co-create, and then we compete with each other. That is the beauty of our industry. And that's why I think that the pace and speed of churn and change that we see in our industry is immense. And I think that is gonna underpin how 6G actually develops down the road. Collaboration obviously is happening, and we saw that was the main reason 5G was brought to the market so early, because typically it took the time it took for 4G to develop the technology in 5G that was cut down by almost 30 to 40%. And we will see the same kind of speed in 6G as well. That the standards will develop very, very quickly simply because we collaborate so well. And it's happening. It's happening in Europe. It's happening in other places as well. I think the one from an India standpoint, one fundamental as an outsider who doesn't live in India, one thing I see very positive about India is at a very right time, at very early stage, India is making the right noises, which has not happened before. We are quite late, I believe. India was quite late in 5G. And as an outsider, I can count now India is in the top 5 countries who is making these right noises globally about 6G. And I think it augurs very well. It's very exciting for the country. Obviously, this is because I think Satish alluded to that as well. He talked about geopolitics. We all know that 6G would be about fundamental societal, changes that would be enabled by 6G, and that is where I think the stakes would be so high, and all the countries are kind of, trying to do whatever they can because the stakes are so high to get early inroads. I guess it'll be interesting to see in the years coming forward.
Yeah, thank you. Now the question to Manoj from Nokia, it's of course the same question, but a little different perspective that I need here is that given that your parent company operates from another country, so is there a conflict? How can these multinationals make a contribution such that India also is a contributor in their larger Nokia ecosystem, for example? So any thoughts on that, please?
I think Satish mentioned about the geopolitical thing. So we at Nokia, we firmly believe in a very, very active regional ecosystem for standardization, right? When you talk about standard, it's all about harmonization, right? Without which nothing will happen. I keep myself reminded on what happened in 3G. When 3G happened, there were 3 different areas in which these standards went, right? You had the Chinese version, TDS, CDMA. GSM actually followed the WCDMA road. CDMA took the CDMA 2000 road. And we could not actually unleash the potential of what the technology could actually bring, right? So I think, therefore, Nokia takes a very, very strong position in terms of having the common positions. That's very, very imperative. So strong, active regional ecosystem, which eventually will lead to rock solid, globally acceptable, harmonized standards. And it is because of this reason that Nokia is very active in more than 300 industry standards organizations, right? More than 300. In India, so it could be ETSI, ITU, And with 5G and 6G, it's important that we also take industry along with us. So we are therefore already playing a very active role in 5G Asia, right? So which is the industrial automation bodies. We are playing a very active role in V2X, NTN kind of standards, right? So eventually we'll have to take a very, very holistic view, right? And I'll again like to emphasize a very, very strong regional active ecosystem for standards.
So that is very, very good to hear, because that's something that's needed, because players like Nokia, who've been in the field for a long time, can help us, a lot in making this journey a reality.
I'll quickly add, we have 50 people in Bangalore, totally dedicated for India in our standards team.
Good, thank you. So now finally moving to Sushil and getting the government's perspective. So there are two aspects here. One is, of course, there are some concerns that have been raised. So I'm sure the government is addressing those already, or is it they are in the pipeline? So we want to hear about that. And then are there some expectation that the government has from the other stakeholders? Because it doesn't work one way, right? The government also probably has expectations from us. So could you please talk of both those things, please?
Yeah. In my opinion, this standardization is a collaborative efforts, and this participation in the global standardization bodies where we submit our requirements and we submit the contributions. And even if we have generated some patents, then those patents should also be the part of those standards. Even ITU and 3GPP are open for that. What I feel, the TSDSI, which has been created by the DOT and the industries, is able to bring the MNC academia and other bodies to its platform. And TSDSI along with DOT, they participate in 3GPP as well as in ITU meetings. Even in ITU RWP 5D meeting, which was held in February this year, the academia and MNC people, they were there. No doubt, sometime the opinion may not be the same from the academia and the MNCs, but what I feel, TSDSI and the government always try to bring them on the common platform, and LMLC, that is the result of that. LMLC was discussed in TEC and decided, and then further it was submitted in ITU and where it was approved. And this absorption of 5GI standards in 3GPP release 17, that is also the outcome. In fact, DOT and TEC have taken it forward to 3GPP, and ultimately the patents which were created by the academia, they will be used in the release 17 standards. So government is making efforts, and it is a continuous journey, what I feel. Yeah.
Right. So any expectation that the government has from the other stakeholders? How can others contribute better?
What I feel, we should have more and more participations. If we compare the Indian participation as compared to China, Korea, and Japan, even we are not having even 25% participation from India as compared to those countries. Even if we, I quote like in study group 20, that is on IoT and smart cities and communities, from China, more than 60 to 70 persons participate physically and virtually both. But from India, hardly 3 to 5 persons participate. And the ITU RWP 5D and in WRC and other organizations, see, our participation should increase. Whether we are participating virtually or physically, it is immaterial. Now the platforms are good even for participation virtually also. If we are able to, we promote our startups and other people, academia, MNCs, to participate more and more in 3GPP and ITUR. Only then we will learn how to prepare the contributions and the participation in standardization activities. And this is less not only in ITU, even in ISO, IEC also. The Indian participation in ISO, IEC is also the lesser as compared to the other countries' participation in those standardization bodies. That we have to promote, and the government is taking this thing also forward. Yeah, thank you.
Thank you. So yeah, so the government is doing a lot. It's setting money aside. It's bringing the stakeholders together. TSDSI is doing a good job. So But yeah, everybody needs to get together and try to make this happen. So after having looked at two relatively heavy issues, let's move to something lighter. 6G is not just about making it happen. It's also about opportunities to be able to do things better. So there'll be newer technologies that will enable. So now I'll go through the panelists and check with them what they think would be those new exciting technologies that 6G will bring to the fore. We'll start from you, Dinesh, if that's okay.
When we talk about technologies, we already know that these technologies exist today, but of course, the potential is huge. Like, for example, artificial intelligence, the blockchain, the deep learning, the machine learning. I mean, these are the technology verticals which will become a critical component or a part of 6G when we talk about standardizations and this. Effectively, what I can say is artificial intelligence, because at the end of it, but I also believe when it'll become, of course, its market will decide, the stakeholders will decide. It's just that we know it could go to that direction it will be all cloud-based. I think entirely it will be cloud-based. It's like a connection, internet connection. You give me a connections, I have the data, I have done the analysis, and I will use the existing applications to gain the intelligence and re-deliver that experience. So as far as technology is concerned, I think the artificial intelligence will play a very major role in 6G communication with deep learning and the machine learning techniques as well. And that is what will determine, because at the end of it, when you see the core technology evolution, you talk about broadband, you talk about latency, you talk about connectivity, the massive machine type communication. So these, on top of this, which will further improve the applications, will make use of these technologies to deliver more advanced applications, because at the end of it, it is latency and data based applications. And we will move from smart to intelligence, because use the intelligence to deliver the intelligence back into this. Thank you.
Thank you, Dinesh. So that's interesting. I have discussed with Satish sometimes about the role of AI/ML. I think he has interesting views there. So before I move to Pradeep, I'd request Satish to say what his opinion is about AI/ML, and also if he'd want to comment on non-terrestrial networks, terahertz, two other technologies that are being talked about. Satish, so could you say a few words on these, please?
Yeah, one of the exciting use cases for 6G that I at least look forward to is what is called as integrated communication and sensing. The whole business of sensing will bring a different perspective altogether, and it will, ignite a whole lot of industry, which like location-based applications did, and a whole lot of applications from all the way from your cab hosting to the food delivery and all the stuff got enabled. But coming to AI, AI is one of the most misunderstood, but whatever flavor of the day. So yeah, it has to be understood that algorithms in whatever way have been used in telecom. And now, whether it is heuristic algorithms as far as AI is concerned or whatever else, it has to be a bit of a level playing field. When people keep talking of AI, they don't even have a definition for AI. But then anything and everything gets classified as AI. That is anyway going to get settled over a period of time. The same discussion is happening in ITU as well. But one has to understand that AI algorithms are, or whatever learning algorithms has its own intrinsic issues. I mean, it may be good today, it may not necessarily be good tomorrow. So there are key things that one will have to understand. One is something called as deterministic determinism. AI algorithms are not necessarily, I'm specifically talking of neural nets when it comes to AI algorithms, because AI is a whole bunch and a lot of class of algorithms. If you talk of neural nets, they basically are generalization algorithms. Generalization, if you go by the word, is bias built into. Any neural net is a bias algorithm. And people complain about neural networks being biased or trying to say that I'm going to take the bias out of it's naturally, it's intrinsic part of the algorithm itself. So these are things which are not very well understood, not discussed. The consequences of which are being discussed. not the intrinsics of the AI algorithms itself. That is something that has to happen. It will happen. And telecommunication networks or military equipment or any of these critical applications will require determinism. You don't have a chance for overlearning, underlearning, etc., etc. Learning algorithms have a place, yes, I agree. But then when you want deterministic output every time for the next 20 years after you deploy, you always have to question whether neural nets fit into the scheme of things or not. And it might, I mean, of course, we will make platforms ready, which will, enable all the stuff. And there are certain intrinsics which will play out, and AI will just be a supporting role, will not be a hero of any 6G technologies, I can assure you that. And that's where we stand. I mean, there are a lot of things to understand about AI, the nature of, there's overlearning, underlearning. It's always good when it is in the right fit, but then, ChatGPT now, you are seeing the backlash. It was good, but now government after government is feeding it. Now, a lot of people think that ChatGPT is intrinsically AI. It's not intrinsically AI. There is an AI algorithm and there's a lot of data fed into, ChatGPT. That's what makes it more powerful. Now, legally or whatever other ground on which you stand, if the people who are feeding the data into ChatGPT is cut off for whatever reason, then ChatGPT is as good as you can imagine. So there is an algorithm part of it, and there is this dumb people who are feeding all kinds of data into it. Now you question whether AI is powerful. Is it the dumb people who are enabling an algorithm with all kinds of data, which you won't have access to as a person? I will not have access to the kind of data that ChatGPT has access to. So there are all these issues which are coming out into the fore. It will play out. It will play out. Government after government is banning, enterprises are banning the use of ChatGPT, not necessarily because the algorithm has its capabilities. Yes, I understand. But what do you say of people who wants to feed anything and everything into an algorithm? That will play out legally, technologically, in all the areas, it'll governance, it will play out and it will settle down. Thank you.
Yeah, thanks, Satish. That's an interesting take. We'll keep ChatGPT out of the conversation because that probably is a few panels by itself. Coming back to 6G and some interesting technologies, your take on it, Pradeep, and possibly a few words on non-terrestrial networks, because I hear a lot of that. Is that coming or will it probably not happen?
Yeah, so just to start with NTN, yes, I think that will definitely happen. Because now that we are moving to, now that release 18 is being finalized, is being kind of laid down, and we see a very strong mention of NTN there. So it is definitely coming. It's kind of drafted in there formally and officially. So there is no escaping the fact it will happen. Yeah, so let us take a step back in terms of how we are evolving. I think some of the underlying technological components, so I see it two ways. One is a lot of the current technologies, they will obviously evolve and develop in 6G as we move forward. And there'll be a lot of new technologies that will come to the fore. So we can have those two buckets in terms of the technological components. On to the first part, the existing technologies. Yes, they will evolve. The AI, I think, well, my view is the AI that we see today is really pre-AI. It is not real AI. That's my view. It is in very primitive state. The AI that would be needed, the AI that we'll see down the road when we get to 2030, when 6G gets commercialized fully, it'll be completely different from the AI we see today. Likewise, if you look at other technological components, obviously it's a given that the data rates that 6G would bring to the table would be a multiplication factor. How do we get to that multiplication factor in reality? So it's things like the QPSK obviously would evolve to something like 64 QAM. So today we are putting in 2 bits per symbol. Tomorrow, moving forward in 64 QAM, quadrature amplitude modulation, we will be putting 6 symbols per bit. So that way we are able to straight away increase the data rate 3 times without necessarily leveraging other techniques which would even take this multiplication factor to next level. So I think that kind of gives you an idea as to how the technological components would evolve. But then there will be new technologies as well. We talk about obviously AI, data-driven design methods, and so on. There is a lot of work happening around the underlying technologies for extended reality. So these things obviously would develop. But I think the other thing is it's not just the technology, it's the experience, it's the use cases. I think a lot of innovation is happening in that space. Today, we have not, this is more of an academic discussion on the technology side today. That comes much later when the requirements are finalized, when ITU has actually defined the budgets for performance budgets for each of these service requirements. So today it was pointed out by another panelist earlier that we are in the phase where we are visualizing, we are defining the vision for 6G. The next phase would be when we actually start to define the service requirements. And after we have defined the service requirements, that is when ITU will take the lead and actually define the performance budgets as to what candidate technologies that would fulfill those candidate budgets can be certified as 6G candidate technologies. So we have not reached that state yet, but I think we are making good progress.
Thank you. Moving on to Manoj. So there's another thing that we hear a lot of, which is something that Satish also alluded to, which is a localization, ability to localize users. So there's talk of terahertz, some base stations being used only for localization and not communication. So that, and what other technologies is Nokia looking at from 6G point of view?
So I think we already talked about AI. So AI is going to be not the only enabler, but it's going to be the bedrock and the foundation for everything, be it radio technologies, core, transport, IP, everything. So that's given. But let's talk about the spectrum technologies. So in spectrum technologies, like Pradeep already talked about the more aggressive spectral efficiencies, that's given. But that we'll also be talking about extreme MIMO, right? Which would be actually 10 times more antenna elements in the base station. So extreme MIMO will be one thing. You'll have to repurpose the existing spectrum bands so that you're able to extract more and more out of the current bands. You'll have to mine more spectrum bands. So if you talk about the extreme coverage, you'll have to look at 400 to 700 megahertz kind of bands. Let's not forget 3 billion people still are not covered in this country, in this world, right? So lots to be done in the extreme coverage side. In terms of the capacities, you'll have to look at 100 to 300 gigahertz, which is the sub-terahertz band for extreme capacities. Let's also not forget about the mid-band, right? So in mid-band, the current C-band will definitely not be sufficient, given the fact that traffic and the data capacities will be increasing, the consumption will be very high. So we are already looking at 7 to 24 gigahertz as the next new mid-band, right? So I think in short, these are the things which will happen in the spectrum side.
So lots of interesting technologies that we will get to see. So moving to Sushil finally. So what is your view on the technologies? Which technologies you think will catch on and which you think are important?
What I feel, the study of terahertz spectrum, that is really very important, and the spectrum even in 6 gigahertz band, that will also be required. And these spectrum study is required in India. And no doubt, globally, all these spectrum studies are going on. And as already mentioned in my previous talk, this in WRC 2024 and 2028, the spectrum may get freezed for the 6G communication technologies. And no doubt, the 6G will be the upgradation of the 5G technologies. What I feel, nobody will be having the standalone network for 6G, like in the case of 4G to 5G. No doubt, in some of the countries, the 5G standalone network, they have also come. So, but we will be having different types of platforms. AI, ML will get evolved. We will be having the blockchain technology also get into it. But the spectrum will be very, very important for 6G technologies. And moreover, this everything will move towards softwareization. Then the security will be a big challenge, not only for the endpoint devices, even for the network and also for the core. The devices, if they become vulnerable, the vulnerability may reach even up to the network and also to the core. Similarly, the core. Therefore, the standards will be very, very important. That the core is also developed based on 3GPP standards, and ORAN and other things. They are also based on standards, so that we are having the secure network from device to the applications. Thank you.
Thank you. So lots of interesting questions still to be asked, but we sort of running out of time. There's talk about open source. There's talk about terahertz. There's lots of other things, use cases we weren't able to allude to. But now we see such an interesting audience here. We take a few questions from the audience. A couple of questions from the audience. Maybe one or two questions from the audience, please. Yeah.
Namaskar. I'm Dr. Jagdish Shivhare, professor and ex-scientist ISRO. Sir, my question, is there any well-recognized survey or research paper that how the 6G technology will achieve the UN Sustainable Development Goals in terms of human, physical, and digital worlds?
So you talked about sustainability. It's such a pertinent question. So I think the target of 6G should be that despite the fact that 6G will be 10 times the 5G capacity, we should look at power consumption of the network half. I mean, that's the aggressive target we should be taking it. So sustainability is going to be extremely crucial in that sense. So the reason is very clear, because the total quantum of this is despite the fact that the energy efficiency is improving, but because of the densification of the networks, because of the more quantum of traffic, the overall consumption of the network will still rise. So I think that has to be addressed.
Yes.
Yeah. There are two things: sustainable ICT and ICT for sustainability. And even this, if we are creating ICT networks that if it increases 2 to 3% of the greenhouse gases, but it will reduce more than 20% of the greenhouse gases. So this ICT will certainly improve the sustainable development goals. And ITU itself has mentioned that the IoT and ICT technology will be able to beat the sustainable development goals by 2030. That is the target mentioned by ITU. And even 6G will come after 2030. Yeah, thank you.
One final question here from, or we'll take both. So just two more questions, one from there, one from here. And then
it's just an observation on what Mr. Sushil said. I think the point you touched initially is very relevant, but then I don't agree with the conclusion, and that's what the topic of my talk would be tomorrow. I'll not come up on that. The point is sustainability. When we talk about SDGs and sustainability, let's not mix up these two things. Sustainable development goals is not only about carbon footprint or energy efficiency. It's about prosperity. It's about education, innovation, everything. So that's where 6G will help. All these technologies will help. They'll bring a lot of all this connectivity, the unconnected, all these things are there. But then there's a balance that we need to look at, where the basic issue is carbon footprint of the digital infrastructure growing. So that's where we need to be cautious. And I don't think the way carbon footprint of digital infrastructure is growing, it will be ever be able to mitigate the benefit that it brings. That is a point of discussion separately. But thank you.
Thank you for your comment. The last question, gentleman there.
Good morning, everybody. This question is basically, I was talking to a gentleman, I was listening to a gentleman from UK who was coming. He was talking about the actual definition of 5G itself. So, well, 5G is there, we talk about SA and NSA debate. I don't think that NSA mode itself is a 5G because of the, they are carrying that legacy EPC architecture in the core. This question is addressed to a gentleman from Nokia. See, today we are talking about 5G and we're talking about kind of speeds and other stuff. The packet is the core everywhere. It's all standard cloud-driven software-based. We're talking about a legacy hardware is a gone architecture. Now let's talk about the reality nowadays. The quality of the service, which is actually, I'm coming to the quality of service, is gone pathetic. I recall, almost 30 years in telecom, the call quality was at least good in the 2G network. We were direct circuits, dedicated circuits. The moment the IP transport is there, I'm telling you, 30-40% of times, I keep saying, "Meri awaaz aa rahi hai kya?" And and the other say, "Yaar, wo to gayab ho chuka hai." It has happened to me a couple of times. Now coming back to the 5G, the ecosystem. We are talking about FR2 bands, right? So where are those radios available in the terms of, since you are in Nokia or Ericsson, whatever, where are those systems available? Of course, this is more suited towards the kind of enterprise and the private 5G deployments. That's where the most of the money is going to be coming out, not really consumer specific. Even if you look at the handset models itself, how many of your mobile phones support a millimeter wave? The same Apple handset, which is available in US, support a millimeter wave band, but not here in India. The same Apple manufacturer would not support a millimeter wave, right? FR2 bands I'm talking about. So in the current scenario, if you look at it, we are still, kind of trying to catch up the real 5G. It's, of course, it's good to look into our 95 gigahertz to kind of 3 terahertz kind of frequencies. So the question here is, I wanted to ask about the ecosystem of the 5G maturity so that we can have a seamless translation towards the 6G system. I'm talking about the issues in the current platform where we are going to be stabilizing this 5G is the question. This is more towards my Nokia gentleman. Okay.
So you talked about the quality of experience, right? So quality of experience is function of many things, right? It's basically function of the network planning. And let's not forget, India is experiencing one of the fastest 5G rollouts. So rollouts are happening. It's going to take some time before you really experience the true 5G experience. So that's given. Another important part you mentioned is the device ecosystem. Typically, device ecosystem and network ecosystems should be synchronized, but that's not the case. Like you mentioned, millimeter wave. So devices are a little late. So moment you have the synchronization of the network and the device ecosystem, you'll start to get the more experience and the real benefit of 5G. So when you talk about 6G, don't look at 6G only in terms of the traditional metrics, right? In terms of the speeds, the density or latencies. I mean, that's given, that will happen. 6G is going to be a lot more transformational in the sense that it talks about sustainability. I think the discussion we just had. It talks about security, cyber security and privacy. It talks about digital inclusion. So these are three additional pillars, and that's the reason 6G is supposed to be much more transformational than what we are thinking about. So I hope so that's what I said, the device ecosystem.
We'll catch up. Thank you very much. Thanks to all the panelists. Back to you.
Thank you, Professor Brijesh Lal. Thank you so much. So, ladies and gentlemen, I've been hearing that 5G was in hurry-burry, 6G we have enough time. Let's see what the 6G ecosystem going to be. So before we have the tea break and the inaugural session, I would like to inform it's a proud moment for all of us that Mr. Pradeep Bharadwaj, who is here from London, he has been appointed as the High Sheriff of Wisley in England 2 weeks back. So congratulations, ladies and gentlemen. It's the first Indian, I believe, who has been appointed. It's like an equivalent to a governor in India, and that's what I've been told. So congratulations, Pradeep ji, on this appointment. My request, the chairman to present the mementos on behalf of our Bharat exhibition to all the panelists. First to Manoj Gurnani. To Pradeep ji. Sushil ji. And to Dinesh. And for Satish, we will send across to you the memento. And my request, Mr. Amit Marwa to come and present a memento to the Professor IIT Delhi. Thank you, sir. We'll have a quick 10 minutes break. Everybody is here for the next panel. So we'll start the next session first. 10 minutes break.
Now, we're driving the next evolution, where networks meet cloud, alive with intelligence, enabling people, machines, and devices to interact in real time like never before, and making high-performance connectivity more consumable, adaptable, autonomous, open to innovation, to collaboration, networks that sense, think, and act. Because by working together with service providers, enterprises, and the world, we can create a more sustainable, productive, accessible future. By accelerating the impact of digital to reach people, places, and industries that have never been reached before. That demands more than change. That demands transformation. For us, that means pushing further with a clear vision and a new logo that symbolizes our purpose. Because it's only when all the right pieces act together that brilliance happens. The precision of tech leadership, the dynamism of a new digital era, and the kaleidoscopic colors of innovation. This is Nokia, but not as the world has seen us before. We always connected people. Now, we create technology that helps the world act together. Networks are evolving from connectors of humanity and technology into something far more powerful. When networks meet cloud, they become amplifiers. Everything to life with intelligence, fueling innovation, inspiring collaboration, enhancing sustainability, unlocking new ways of working that are reshaping the way we all live. Harness the exponential potential of networks. Transform your business to the power of N.
When communication can save a life, when sensors can prevent environmental catastrophe, when a tablet can teach a child to read, no matter where in the world he may be, one company responds by accelerating the promise of an intelligently connected world and sits at the center of it all. Seamless transactions, urgent alerts, personalized messages sent securely and reliably around the globe billions of times a day, connecting the world's mobile network operators and powering the global communications technology of Fortune 2000 companies.
Hello.
One company is driving the innovation needed to harness the explosion of connections that will shape the future for generations to come. Because connections are what make us human, and they begin with us. Cineverse, the world's most connected company.
Too early to talk 6G? Not for wireless communications researchers. Research for a new generation of mobile wireless communications starts more than 10 years ahead of initial deployment. Launching 6G in 2030 means research has already begun. 6G will allow new, exciting use cases above and beyond 5G by combining sensing, imaging, precise timing, and intelligence at the edge with the mobility of wireless. It will further integrate communication and compute technologies into society, including using and expanding AI applications. Early 6G performance targets represent a 10 to 100 times increase over 5G, up to 1 terabit per second peak data rates, connection density of over 1 million devices per square kilometer, and centimeter level precision positioning. Frequencies above 100 gigahertz will enable ultra-high data rate short-range networks. Precise timing requirements will bring time-engineered networks and applications and will require changing how networks operate. Delivering 6G demands significant advances in computing and networking architectures, chipset designs, radios, antennas, and materials. Exponential growth in data traffic will bring spatial spectral efficiency and connectivity challenges. Extreme modulation bandwidths and shorter wavelengths will reduce beam width and increase antenna and device integration. Radio resource optimization and intelligent networking will also require innovation in RF, baseband, and system design. Significant technical challenges are on the horizon for wireless design and test engineers. While continuing to enable 5G development and deployment, Keysight is also active in 6G programs around the globe, working on solutions for the 2030 wireless era. Our current solutions provide advanced capabilities that test far beyond 5G. With Keysight, you can build 5G today while preparing for 6G tomorrow. Explore your options today.
We've been adapting to change for over 150 years. Now, we're driving the next evolution, where networks meet cloud, alive with intelligence, enabling people, machines, and devices to interact in real time like never before, and making high-performance connectivity more consumable, adaptable, autonomous, open to innovation, to collaboration, networks that sense, think, and act. Because by working together with service providers, enterprises, and the world, we can create a more sustainable, productive, accessible future. By accelerating the impact of digital to reach people, places, and industries that have never been reached before. That demands more than change. That demands transformation. For us, that means pushing further with a clear vision and a new logo that symbolizes our purpose. Because it's only when all the right pieces act together that brilliance happens. The precision of tech leadership, the dynamism of a new digital era, and the kaleidoscopic colors of innovation. This is Nokia, but not as the world has seen us before. We've always connected people. Now, we create technology that helps the world act together. Networks are evolving from connectors of humanity and technology into something far more powerful. When networks meet cloud, they become amplifiers. Bringing everything to life with intelligence, fueling innovation, inspiring collaboration, enhancing sustainability, unlocking new ways of working that are reshaping the way we all live. Harness the exponential potential of networks. Transform your business to the power of N.
When communication can save a life. When sensors can prevent environmental catastrophe. When a tablet can teach a child to read, no matter where they may be. One company responds by accelerating the promise of an intelligently connected world and sits at the center of it all. Seamless transactions, urgent alerts, personalized messages sent securely and reliably around the globe billions of times a day, connecting the world's mobile network operators and powering the global communications technology of Fortune 2000 companies. One company is driving the innovation needed to harness the explosion of connections that will shape the future for generations to come. Because connections are what make us human, and they begin with us. Cineverse, the world's most connected company.
Too early to talk 6G? Not for wireless communications researchers. Research for a new generation of mobile wireless communications starts more than 10 years ahead of initial deployment. Launching 6G in 2030 means research and 6G will allow even exciting use cases above and beyond 5G.
May I request all of you to please take your seats? We are running late. Ranjit, can you? Request those who are having the tea, please bring with the tea. Please come with a cup of tea. You can have it on the table. Good morning, once again, ladies and gentlemen. The inaugural session, Network Evaluation Beyond 5G and India's Vision for 6G. That's going to be the name of the inaugural session. I invite all the distinguished speakers and the guest of honor for the session. May I invite Shri T.R. Dua. Please come on the stage, sir. Shri Vijay Christopher, who is the guest of honor, Wireless Advisor, Department of Telecom. Ladies and gentlemen, please give him a big hand. He is our guest of honor. My request, General Kochhar Sahab, Director General COI, come on the stage. Mr. Amit Marwa, CMO Nokia, please come on the stage. Amit ji. Devi Gandhi, President, Regulatory Reliance Jio. Then we have two speakers who will be joining us online. Dr. Isam from the 3GPP and Ms. Eva from Telefonica, Germany. May I request Amit Marwa ji to Amit Marwa ji. Okay, I request Brigadier Sanjay Rawal from Signals Indian Army. Brigadier sir, please come on the stage. As everybody says, spectrum, spectrum, he is the one who has to give us the spectrum. Brigadier sir, please come. Amit ji, please come. So before we start the hot discussion on the inaugural session, discussion on 6G, may I request Christopher sir to light the lamp along with other distinguished speakers.
Vakratunda Mahakaya Surya Ko Samaprabha Nirvikhnam Kuru me Dev Sarvakareshu Sarvada. Vakratunda Surya Koti Samaprabha Nirvikhnam Kuru me Dev Sarvakareshu Sarvada.
Thank you, sir.
Vakra
India is already looking beyond the adoption of 5G technology to develop and deploy its faster and superior successor, the sixth generation of telecom network, so-called 6G. The Bharat 6G vision is out. We are the 2030. So we have enough time to discuss the 6G ecosystem in India. May I request Shri T.R. Duaji, Director General, DIPA, which is called DIPA. He changed the name from earlier, from the Tower Association, sir, to give the welcome speech. Shri Dua.
Good morning, ladies and gentlemen. I'd like to thank the organizer for giving me an opportunity to address such a august panelist. I think, Shashi, you're playing a game with me, looks like. Nonetheless, I'm glad that I get this opportunity. This is a panel, I think, comprised of very, very high fly and people who know the subject. Thank you very much being there. I'll just quickly give a short brief. First of all, this welcome address or network is the network evolution beyond 5G and India's vision for 6G. If you look at every decade, the world bears witness to yet another highly improved generation of technologies, wireless technologies, that changes the way the future of communication is perceived. Each new generation provides an almost disruptive impetus to the state of technological advancement. It spearheads the societal change and leaves the world wondering if we have truly understood how limitless communication technology could be. Further, mobile wireless communication have without a doubt transformed the lives of people and the global economy over the last 3 decades. Wireless technology harness the power of internet to morph the daily lives of the people and intertwine them into a digital world. From the first generation of analog technology to the 5th generation of wireless broadband technology, having seen this evolution right from 1994, early 1994 to date, I think it's a great evolution. The advancement of seamless network has made accessibility and affordability well within the reach of the common people. The result can be seen in India too, which went from a country, if you look back, of 20 million landlines in 1998 to more than 1 billion mobile telephone subscriber today, with over 85% of the subscriber having broadband connectivity irrespective of their location. With this, I think if you recollect, on 1st October 2022, the Honorable Prime Minister of India launched and flagged off the official launch of the 5G services in India, thereby putting India into the map of being a 5G enabled country. No more laggards. While the rollout is still in progress, it is expected to proliferate to every nook and corner of the nation by, say, early 2025. The arrival of this next generation of network is highly welcome, and we do anticipate to become a catalyst in realizing the digital value of across the country. Within just 200 days, we have been able to launch 5G in 600 districts, and with almost close to 150,000 BTSs. Every day, technology is evolving. Computers are getting faster, cars are getting smarter, and communications are more accessible than ever. With this, I don't think I'll take time because I like to leave this with our friends on the panel. Just by closing this by saying 6G requirements are huge. There will be increase in mobile computing requirement. Maybe they need to relook at the battery size. 5G has been designed to achieve 20 Gbps peak data. 6G, if I understand, would have peak of around 1000 Gbps with a user experience of 1 gigabits. Latency targets which have been set are far lesser than what 5G expects. And recently we have witnessed a dramatic rise in wireless data traffic, which has been brought forth by the numerous exciting technologies in wireless and assisted by the pandemic impact. This exponential growth has been accompanied by the demand for higher data rates, better coverage. Even as the 5G rollout continues worldwide, leading research consortiums and mobile companies are busy working on their 6th generation mobile connectivity. 6G network aims to connect physical and virtual worlds through faster M2M communication and better support for immersive technology. Organizations, institutes would know about the working and importance of 6G network to prepare for the future and fully use the wireless infrastructure available. Thank you so much.
Thank you, Dua Sahab. Now, may I request Dr. Ihsan, who is on the line, who is the Director, 3GPP Mobile Competence Center. Ihsan, are you there?
Hello, good morning. Do you hear me?
Yes. Go ahead.
Great. Thank you very much. Hello, and good morning, ladies and gentlemen. I am Ihsan Tawfiq, the Director of the 3GPP Mobile Competence Center in ETSI. And it is truly a pleasure to give this introductory address today in 6G India. This event, together with many other initiatives taken by India and the Indian government, show the great work and effort put to put the country in the forefront of developing the emerging technologies like 5G, 5G Advanced, and 6G. And one of the aspects of this effort and this work is collaborative cooperation and collaborative work in the international level, and more specifically, this is one domain I come from, which is the standardization. And I would like to put here a little emphasize on the great work done in cooperation at the standardization level of cellular systems. And I would like to mention here the great collaboration going between TSDSI, the Telecommunication Standard Development Society India, and ETSI, which is the European Telecommunication Standards Institute. There has been a cooperation agreement signed between the two institutions back in 2014. This agreement allowed TSDSI to adopt and publish ETSI standards, and also allow ETSI to adopt and publish TSDSI standards. Both organizations are also partners in the 3GPP. 3GPP is the organization responsible for developing the standards for 5G and hopefully for 6G as well. Since it joined in 2015, TSDSI has transposed and published about 1,500 specifications produced by 3GPP. And these specifications has then been sent to the Telecommunication Engineering Center, Department of Telecommunications, for their adoption as a national standard. So 3GPP is where work in 5G is happening. And before we start, and I start talking about 6G, I would like just to take a moment to see where we stand in terms of standardization of 5G. Currently, 3GPP is actively working in release 18 of the standard. This is the first release of the 5G advanced. And this year gonna be a very, very busy year, because in addition to completing the work in release 18, 3GPP will be looking also on defining the content of release 19. And I put here in this slide, as you could see, in June next month in Taipei, we will have the 100 TSG of 3GPP, which is in itself a big achievement. But we will also have release 19 workshop where the content of that release will be being defined. The timeline for the completion of release 18 is the end of this year. So by December, release 18 should be frozen for the functional side, and then for the codes in March 2024. And work will then start in release 19 with a timeline to finish this release by September 2025. Release 19 is not expected to address 6G. It's going to be 5G and 5G advanced only. So the first release expected to start studying 6G will probably be release 20 for the study work, and then maybe release 21 for the normative work. We're looking at 5G in terms of deployments. According to GSA, there have been around 250 networks commercially launched around the world, but only 40 out of these 250 are standalone. So we are still a little bit behind in the standalone development, which is the full 5G package. This is not what we had initially expected. We were expecting a much faster launch of standalone 5G. When it comes to India, as have been mentioned earlier by the previous speaker, and as we could see in the announcements, we see a very fast deployment since the launch in 2022 with new 5G networks in many cities and many towns. So when looking at where we stand on the standardization and the fact that at least for the coming couple of years, there will be no standardization work in 6G, and we're looking at the deployment, one may legitimately ask, is it time to start talking already about 6G? And the answer is yes, because there is a requirement for more time, or it takes time for ADS to mature from research to standardization. Governments need time to develop and funds for helping these research activities and for these projects to mature enough to be able to make it to the standardization work. It takes time to develop a vision and a consensus about what the next generation should be. And all this work on research and trying to develop a vision has given birth to many initiatives across the globe and in the different regions. So in specifically for India, we saw that the Technology Innovation Group on 6G has constituted 6 task forces to deliberate on various aspects of emerging telecom technologies and platforms in the next decade. The government of India has released the Bharat 6G vision document prepared by this TIG6 group. So all this work across the globe, as I said, is taking place by different parts. But what comes out of it is more of a consensus view on what the 6G should be like. So even though we don't know yet exactly how 6G in terms of technology or use cases will clearly be, but at least there are a few trends that start to emerge based on this work. So we from the different white papers, from the different presentations, we see that 6G is more about merging the physical, the human, and the digital world. We know that there will be more intelligence in the network in order to better use the available resources and provide the best service to the customers. We talk about secure by design, so more security, sustainable also by design. So talking about energy efficiency of the network, but also what 6G will help the industries achieve on terms of sustainability. So there are many trends, as I mentioned, that emerged in terms of use cases and in terms of characteristics of 6G, but there is also some trends that start to emerge in terms of what technology 6G will be about. So we are talking more and more about terahertz communications. We are talking about reconfigurable intelligent surfaces, integrated non-terrestrial and terrestrial networks, et cetera, et cetera. And I would like just here to mention that some of this work in pre-standardization already started in some areas. And in ETSI, for example, we already have some work ongoing on terahertz communications and reconfigurable surfaces. So the question again that we may ask, looking at all these different initiatives popping up around the globe in different regions independently, is there a risk of fragmentation? And probably history here give us some answer, because similar thing happened with 5G. At the early days of 5G, we saw initiatives and activities happening in different regions, but this did not prevent 5G to be a global standard. I believe that this stage there is consensus within the technical community. There is a consensus within the industry that 6G also needs to be a global solution. Industries do not want to start having different chains or production lines for the different 6G solutions. Customers do not want to go back to the early days of cellular communications where we had to change phone every time we had to go to a different country. So for both industries and customers, 6G would need to be a global standard again. And I believe there is consensus on this. And hopefully we will also see that at the political level, and we see that the geopolitical situation is with us for a few years to come. And hopefully this will not prevent 6G to be a global standard. With such a positive, hopefully positive note, I would like to conclude this introductory address by thanking the organizers again and wishing 6G a very bright future. And in the coming 2 days, we will be hearing a lot about 5G deployments, but also what 6G hopefully will bring as improvements for both industries and customers. Thank you very much.
Thank you, Dr. Ihsan. Now may I request our guest of honor, Shri Vijay Christopher, Wireless Advisor, Department of Telecom, Ministry of Communication, to address the gathering. So.
Very good morning and distinguished speakers on the podium, delegates who are participating from academia, R&D, startup, and other government participants, and ladies and gentlemen. It's a pleasure for me to be here for this 6G event that we are organizing for this 2 days conference to discuss the regulatory, technical, and other aspects of 6G and discuss in detail about the opportunities and challenges that lay ahead towards the realization of 6G. We hope that out of this deliberations, this conference would be able to give us some recommendations that can act as a takeaway for all the stakeholders. As you know, this global harmonization and standardization of telecom technologies take place under the aegis of ITU, International Telecommunication Union, for the development of ICT. In the year 2020, ITUR has come out with a framework called IMD 2020, which gradually developed into a 5G that we are seeing today. The work is in progress and innovations are going on in ITU for the next generation of IMT, which is named as IMD 2030. And we hope that that will evolve into the 6G that we are talking today. WRC, World Radio Conference, is the apex body of ITUR, which revised the radio regulations, which is a document that governs the use of radio spectrum as well as the satellite orbital resources. So the 39th edition of WRC is going to happen in this year. In October, November this year. And we are hopeful that it will decide on some of the spectrum bands for the 6G, among other radio communication services. And also, this will decide the study cycle for the different applications and services in the next 4-year cycle, that is 2024 to 2027 until the next WRC 2027. So these phases are very critical for the development of 6G. From the government perspective, I would like to brief about the spectrum, what we are doing with the spectrum. As you know, in WRC 19, they have identified the spectrum for 5G, which government has cleaned and auctioned in the year 2022. So we have 5G, especially that band 3300 to 3700 megahertz, as well as the band millimeter wave band, popularly called, from the 24.25 gigahertz to 27.5 gigahertz. So this is already in place. As you know, as is already stated that 6G is an evolution of 5G. So this band also will come into play. Apart from that, some of the other activities regarding spectrum, I will just briefly tell you. for further expansion of IMT and 6G, additional IMT spectrum in the higher frequency ranges, that is from 37 to 43.5 gigahertz, 47.2 to 48.2 gigahertz, and 66 to 71 gigahertz bands are being also planned while taking care of the existing service. Also, government is also in the process of making available V band and E band. V band is from 57 gigahertz to 66 gigahertz, and E band is from 71 to 76 gigahertz and 81 to 86 gigahertz spectrum. We have also sent a reference in August 2022 to the TRAI for recommendation regarding the assignment of E and V band. Also, you may be aware that on an interim basis, government has allocated 2 carriers of E band of 250 megahertz for all the TSPs who is holding access spectrum in the IMT bands in the LSAs. DoT has also decided to open up a radio spectrum in terahertz band beyond 95 gigahertz for experimentation. A reference has also been sent to TRAI for providing recommendation on this terahertz bands. This would provide impetus for local manufacturing and development of use cases in the higher frequency band, as terahertz is going to be a critical band for the 6G. And apart from that, the mid band 1 to 7 gigahertz, which is most critical, which provides good coverage and capacity. DoT is also working on further identifying new spectrum for IMT in this mid band. And you may recall that most importantly, DoT has already simplified the process of experimentation of any spectrum band in the year 2019 for ease of doing R&D. So this band is available, R&D or any testing experiments can be done just by paying 5,000 rupees to the DoT per year. In the ITU calendar for 6G, Working Party 5D has already released ITU report on the future technology trends of terrestrial IMT systems towards 2030 and beyond in November 2022. Also, works are underway for the development of recommendation of IMT framework for 2030 and beyond in the same Working Party 5D. Now, this Working Party 5D is expected to ramp up its major works towards its objective from the 45th meeting which is scheduled in the year 2024, where it will be considering the critical technical specification requirement and evaluation criteria that is going to come from next year onwards. DoT is now taking a constructive and collaborative approach by involving industry, TSPs, academia, research institutions, etc., to identify the key areas of work and build a synergy to innovate, create IPR, standardize, contribute to global standard, create specification and technical regulation. As a big facilitator, DoT is there. You must be knowing that recently DoT has a technology innovation group on 6G, TIG, has brought out a vision document for 6G. That roadmap, vision document gives a roadmap for 6G in India. They have commented in that report. 6G will build upon 5G technology and provide more reliable, ultra low latency and affordable solutions 100 times faster than 5G. These advances will impact not just user experience, but also transform economies and lives everywhere. India must focus on allying its research on technologies that would propel the implementation of 6G in India in highly customized manner. India will have to identify priority areas for research by involving industry, academia, service providers, spanning simulation studies, POC prototypes, demonstration, and early market intervention through the startups. The TIG has also identified the focus areas for research. They have given recommendation for that. Also, TIG has recommended the need for gigabit Wi-Fi spectrum in the 5.925 to 6425 megahertz band for offloading the indoor traffic and complementing 6G effectively. These are taken from their recommendation of Innovation Group on 6G. While concluding, I would like to list out the two strengths, rather advantages for India. One is the soft power, and the second is software power. Soft power, it comes by virtue of its culture, religion, music, movies, and things like that. We can diplomatically use it for the international participation for these conferences all everywhere. We can drive the agenda using that. Second thing is software power that you should know. You may know that we are considered one of the superpower in software. I think we should leverage these two concepts as the digital twins for the favorable 6G outcome for India in the next coming, I think, 5-6 years. When 5G non-standalone case came up, it was a upgradation of 4G. Rather, it was a software very lavishly used. It was kind of a software upgradation with less hardware. Similarly, we have the strength in software. Can we drive that development into that area while doing R&D or doing experimentation in this working party 5D, which is going to take a call? But it is also vital that at every meeting from next year onwards of this working party 5D, we should be able to come out with contributions of substance from the R&D and startup. And we should be ready with the simulated prototype at each meeting of this 5D where it matters, so that we can influence in delivering a 6G, which is India specific and for the globe. We should not stand alone. We should not do any pre-standardized things. We should move along with that. Then only we can make it for the whole world. And this TIG has specifically, the keyword they are saying in their recommend is highly customized manner. We will have to focus our research. If we can succeed in this mission, then we can take it up in this 3GPP or whatever this thing, we can come out with our model. I would like to thank the organizers of this event for this invitation and wish all success for this event. Thank you very much.
Thank you, sir. Thank you for highlighting from the wireless department of the Ministry of Communications how the 6G should be. Now, ladies and gentlemen, where the spectrum is lying. So the most of the spectrum is with Army, right? The defense. So I request Brigadier Sanjay Rawal from the signals from the Indian Army to give his talk, what they are going to do on the 6G. Thank you, sir. Brigadier Sanjay Rawal.
Good afternoon, everyone. I firstly thank the organizer, Sashi, from the Bharat Exhibitions for having firstly organized this event, important event, and given this opportunity for us in the Defense Forces to speak. Normally, the Defense Forces are not part of these conversations, discussions, and it's a unique opportunity he is given, and thank you very much. And the panelists which we have today, I feel I'm amongst the top-notch giants of this particular field. And I, with my humble background, am part of the panel. So it's a privilege. And more than that, it's a privilege for me to have my ex-Signal Officer-in-Chief, General Kocher, in the panel. So it's a unique privilege for me. What in this particular discussion we are having is the network evaluation beyond 5G and India's vision for 6G. It's an important topic where we are thinking ahead and talking about the vision. Where exactly do we pitch in as armed forces, defense forces? And this is what I'll be covering. This particular photograph which you see, the slide which we see in front of me, is Habba Khatun. A folklore, you Google, it is in the Gurez Valley. To reach Gurez Valley, you have to cross the Razdan Pass. Razdan Pass is closed for about 6 to 7 months in a year. And there is a Peer Baba ki mazar wahan pe. Every vehicle which crosses that Razdan Pass stops. So reaching this beautiful place where this Habba Khatun peak, which we are seeing, is next to the Kishanganga River. And 2 years back, when I was there, we had a single RR of 2 MB, which was extended to this particular place by about 8 hops. And for the civil populace, we just had 2 channels on a satellite link. And today, I just visited this place last year. It is a wonderful place where I had the TSP, my mobile was working in that place. So we must take pride in this, where the TSPs have extended to these places, where the DOT has reached out, provided these particular provisions. As we go along this Kishanganga River, there's a subsector called Neeru Borough of Chakwali, NBC subsector we call it. And ahead of this NBC subsector, Neeru Borough of Chakwali, is a small place called Abdullah. It's a village of about 75 people there, not less than that. And in this particular place, we had an occasion where a report of some infiltration group came in. And how I relate, what is the vision? And I feel thrilled that we are having a particular time where 5G is getting rolled out and we are talking about 6G. I feel thrilled. Because in that particular operation when we had, we were so many things had to be coordinated. As a commanding officer of a signal regiment, I was sitting in the exchange for about 4 to 5 days. We were supposed to be coordinating the cordon of 5 battalions of the locations which we are not sure. The guns which had to open fire was trying to coordinate where is the FLOT, the forward line of troops, so that we don't have a fratricide. And in this, there was so much of pressure of giving back the information to the control headquarters, where they wanted real online things. Now, what is promised in the 6G? That tactile internet, the ubiquitous communications. Wonderful, wonderful. I'm thrilled. I'm thrilled to have this particular thing. The issue which is important, there's a key difference between today's networks and the future networks is what? It is totally based on entire new technologies. What we're getting, totally new technologies. And where is the challenge? The challenge is we have to be interoperable with the current generation of networks. This is a challenge. So when 6G is an abstraction, and as defense forces, we were looking ahead. How do we go ahead? This wonderful book, The Great Tech Game. We must have heard about the great game. Each line of this particular, the deeper you look into past, the further you look into the future. Technology is the new wealth of nations. We are going to experience 20,000 years of technological change in the next 100 years. Success determined by ownership of infrastructure, technologies, code, and data. Geopolitics of technology Silk Roads. Now, next important, control and ability to defend one's network and damage those of the opponents. Extremely potent in case of future escalation of conflict. Along with the military might, go back, look at the World War. Communication and communication intelligence and decryption. You must have heard about Enigma. Enabled American and the British to win the world wars. Today, internet is making rivalries more volatile and cyber attacks too easy to carry out without waiting for diplomacy to do its job. While we talk about the future, the development and the progress which the country is going to make, the security of the nation is of paramount importance. We cannot forget this. The messenger gods of battle, Tony Devros. Now, radio, radar, sonar, these are wonderful things. These are wonderful things when we fought the Second World War and we continued for some period of time. But as we are going ahead, the digital war, this book written by Winston Ma is how China's technology power shapes the future of AI, blockchain, and the cyberspace. What are the future was likely to happen? This book, The Last War by Praveen Sahni, he says the war will be swift. It will finish in next 8 to 10 days. Whereas the other book, Salami Slicing, is how exactly is China doing the way what it is doing. A different concept. So making sense of different views, how do we relate? How do we relate 5G? And this is a statement, there's a war going on over 5G. And they say it's not a conspiracy theory. Good thing, 1994, Huawei was a minor domestic player selling switches for telephone networks. And its founder, Ren Jingji, met China's leader, Jiang Zemin. Ren, a former engineer with the People's Liberation Army, the PLA, who went into consumer electronics, played the patriotic card, cautioning Jiang that this is important for all of us. Switching equipment technology was related to national security, and that a nation that did not have its own switching equipment was like one that lacked its own military. A quarter century later, 25 years, today, other countries led by the US have belatedly grasped the wisdom of Ren's remarks. The technology in question today is 5G and Huawei's equipment that they regard as a danger to their national security. They're regarding it as a danger to their national security. Chip war. There's another interesting book. While the chips are being made in a particular place, other countries are trying to reach out. But the chip manufacturing machine is being made in one particular country. To get that is a challenge, and it is a national level challenge for all of us. How do we go into this? The issue is semiconductor technology is going leaps and bounds, and what Mr. Christopher has covered, what the previous session covered, academia is doing a wonderful work. I'll not comment on that presently because I have not seen it yet. But these are the challenges which are there. So, as we're talking, the 6G arms race has already started off. From a military point of view, what are we looking at? The world is breaking apart literally and metaphorically. From a climate point of view, all tanker-sized chunks of polar ice are disintegrating into unprecedented rate. Tribalism is resurgent. Supranational bodies like EU, NATO are under threat. Identity politics are rife. It's a fact of matter. The telecom industry is witnessing its own breakup after a long period of globalization that culminated in development of single international 5G standard. The first 5G standard is live. The real danger is what comes after 5G. And this is the question we debated. The ETSI, he covered in his talk just two talks before. In the morning, it was covered. The geopolitics is impacting. So the world has had several competing standards before, but not amid the levels of hostility, protectionism, security-related anxiety that exists today. Political leaders have bought into the idea that 5G is the most important technology of the 21st century, raising the stakes even higher for 6G. So, as a proud Indian, as a proud person in uniform, how will the 6G roll out? Now, you see this particular foil in front of you. It's interesting. It's interesting. The network, those flashy lightning symbols which we have, network is going to be the glue, where we're going to have various platforms, the various data and various time frames. And whatever we talk about in 5G and slowly propagating over to 6G gives us tremendous opportunity in various use cases. You name a thing, I got a use case in it. You see this valiant soldier in a Sikh turban. He's a soldier in a system. I got 10 use cases for him. We see the guns. We got guidance systems. We got loitering munition system. We see a drone. The present war which is taking place in Ukraine, there are a number of use cases. So how does it roll out? Before rollout, this is a photograph of 2014, J&K, where the floods came. And everything came to a standstill. Everything came to a standstill. I still remember the Corps commander there. He is saying, thanks to the MCCS mobile cellular communication system, we were at least able to get through and speak to various persons. So this is a challenge for all of us. We talk about the ubiquitous. We talk about the edge. We talk about the mobile communication right at the edge. How do we do it? And this is what we need to cater for. War fighting in mid-2030s. How will it roll out? We'll have intelligence swarms. We'll have a cross-domain mobile warfare, AI-based space confrontation, and cognitive control system. The cognitive word, the intelligence. Now, lot of battlefield information. This information is going to be processed, decision-making. Where is it going to take place? And I have a vision ahead. 6G enable these operations. And as a country, we are proud, we already have the 6G vision statement in front of us. And it's a commendable work done by the government organization and releasing it in the open domain, saying this is our vision. It's a commendable work. And with the vision in front of me, I find this wonderful opportunities which have this. High-speed mass data transfers, applications encompassing autonomous vehicles, virtual reality, AI-powered command and control systems. These are the opportunities. So what are the changes? The changes expected to have the transformative effects on doctrine, our operations, our battlefield conditions. How do China and the US, how do they look into this? Similar, but slight differences. Cross-domain communication networks, surveillance and the capabilities, large-scale big data processing, more devices, multiple frequencies, large bandwidths, integration of AI and machine learning, continuously learn and improve decision-making. That learning, we talked about the AI algorithms. Somebody was saying algorithm, do we have a fixed one? Do we have a learning one? Is there a bias there? Yes, no. Virtual and extended reality training, education, real-time visualization. This is the China's national defense news. What does the Pandayan say about it? How are they looking of 6G in the future operations? Contested logistic, joint fires, joint all-domain command and control. And the key last bullet on this particular thing is the information advantage. This is a challenge for all of us. Information advantage. Now, the holistic management of C4 resources, the joint optimization. The joint optimization is unique. We call it the C4, and instead of this, it's the communication, computation, caching, and the control. The keywords are the communication and computation. And take videos, send the data, edge cloud, learning algorithms, detect anomalies, take decisions, implement. This is my OODA loop. Observe, orient, decide, and act. So where is the key performance indicator? The key performance indicator is the end-to-end delay, E2E. And which are the two factors? Is the computation and the communication time. So the carriage and the content, both are being promised as we are evolving in 5G, and we are looking at the vision of 6G. How best we optimize this particular thing. This slide has been taken off from the 6G vision document, which is there. So we have now 3-4 bands, and what Mr. Christopher covered was wonderful. We are going beyond 30 gigahertz. We are talking about the V band. We are talking about the E band. We are talking about 90 gigahertz, which are there. Now, these are in the realm of academia. I'm not sure how it rolls out, how it proliferates, how exactly it comes out. But my challenge is here. The sub-gigahertz band and the mid band. This is the challenge. Why it is a challenge for me? This is a place where we function. And this, how do I continue functioning when we're having the new technologies coming up? This is a challenge for all of us. This is at the mid band. This is another one, 7 to 24. What Mr. Manoj was highlighting, this is a wonderful band and a lot of opportunities. Yes, I support him. It's a wonderful band, but we have something existing working there. How do I change? A small change in the previous slide has led us to a cascading actions, which I feel will take 5 to 10 years because we have systems running in that. There has already been told a decision taken. In the slide which I showed about Srinagar getting flooded, a small change in the frequency band because of the auction which has taken place recently in the 800 megahertz band. A small change took us, say, 25 days to 1 month to implement that small change of a live living system when everything was available. So these are the challenges in front of us. So if we've seen the challenges, we've seen the opportunities, how do I help out and how do I work? These are the recommendations. Leveraging indigenous 5G testbed experience for 6G. Military College of Telecommunication Engineering, MCT MAU, is a center of excellence. For 5G. We've got a test bed. We can optimize, utilize this particular institution which is there. Ambient sensing. We got detachments right from Kanyakumari to Kashmir, from Bhuj to Bongaigaon. We got detachments. How best we can optimally utilize for this ambient sensing. Data set types and volumes. That slide which I showed with a sick gentleman. We got data types. These are live things. We can actually test out. We have got AI and so many algorithms being talked about. It requires data. The test proof of concept implementation, user-defined virtualized air interface, HAPS, high-altitude platform systems, tactile internet, multi-platform next-generation networks. These are things that can be utilized in a place where it will help. And why I'm saying it's going to be a win-win situation. The adaptation gap will be minimized. The adaptation gap. This is a win-win situation for all of us. So, from the vision, which has already been given to us, a wonderful work done by Ministry of Communications, we're already into the mission. How do we execute it? Thank you. Jai Hind.
Thank you, Brigadier Sanjay Raval, for giving that in-out about how the 6G should be and the recommendations. Ladies and gentlemen, now I request General Dr. S.P. Kocher, who was earlier Signal Officer in Chief, now the Director General, CUI. Sir, General Kocher.
I get caught by surprise every time. I didn't know I have to come and talk here. So I don't have a script. Let me first congratulate the organizers, and I must also congratulate the Government of India and the industry, telecom industry, in the manner in which they're propagating 5G and rolling it out. One of the questions which was given that it will be asked sometime, so I'm going to address that question. It will be simpler for me. Are we ready for an auction? So this is something which will be interesting to you also, but which has no specific answer. I'll tell you why. There are a few ingredients whenever we proceed towards an event like auction of spectrum. And those ingredients are, currently, do we have enough inventory of spectrum? Secondly, going forward in the near future, do we require more spectrum? Do we have use cases to monetize that spectrum? And thirdly, do we have use cases to ride on the spectrum? So because rolling out networks for the sake of rolling out networks has no meaning. Let me take each one of them separately. Do we have adequate spectrum today? No. Answer is very emphatic, no. For the Indian conditions to roll out 5G effectively in the manner it should be rolled out, we require 2 gigabits of spectrum for the type of environment which is prevailing, for the type of number of operators that we have, and that has been statistically proven. What do we have? 800 megabits. We're short of 1200. So we definitely have a requirement going forward. And that is the reason why COI has been asking for this additional spectrum of 1200 megabits in the 6 gigahertz band. And taking a cue from what Mr. Christopher said, I would request him to have a relook at the recommendations that were made. Because in 5G, with the type of capacity and the type of speeds that will be available, is there really a need to offload traffic onto Wi-Fi, which will be the preferred mode of carrying data? Won't it be mobility? That will be preferred. And if we can have the correct type of 5G across the country, ubiquitously, it will happen. This is one. Second is, do we have use cases? At this point of time, nowhere in the world we have use cases which can be monetized. We don't have a killer app for 5G. But my sense is the use cases will develop from India and the world will adopt it. Because India is at the crossroads of a developed country and a developing country. So the requirements of the entire world will be met from here. That is my feel. Till the time we don't have that, we have to lay out an infrastructure which is robust and which can support other verticals to grow on the telecom foundation. And for that, we require support of the government in terms of finances, in terms of the cost that comes on us to roll out networks, and coming specifically to a point, the cost of spectrum. If we are going to continue with the same algorithms of determining cost, it may not be cost effective for the TSPs to roll out networks, because we will not be able to monetize these networks in the next few years. It will happen, but it will happen after some time. So my request to the government and the industry at large here is to really look at, don't miss the woods for the trees. Look at the country's benefit and see that the government and the industry have to stand shoulder and shoulder as partners to roll out a robust telecom network which can be utilized by the other sectors. By looking at telecom only as a golden goose and saying that I will milk whatever money we can from telecom at this point of time, as we've been used to, may not be the correct approach. The approach would be to look at it longer time and see how much more benefit will come if we let the other sectors, automobile, medical, agriculture, you name it, it'll all have applications. And the way they will grow, the way their productivity will grow and increase the country's GDP and contribute to the coffers of the government is something which we must look at. And therefore, see that we jointly roll out telecom networks which are robust. I think I'll stop here because this is something which I had to say something. So I have tried to talk about the current situation which is prevailing and of the near future. 6 questions are thrown at me. Thank you.
Thank you, sir. May I request Mr. Amit Mawa, Head of Marketing and Corporate Affairs, Nokia, to address the gathering.
A very good afternoon to all of you. And it's an honor to be part of this esteemed panel. Maybe I'm not the youngest, but in all respects, I feel I am the youngest amongst all these people. I have mentors here sitting, Mr. Dua, Khocharji, and Anilji sitting there, who have been mentors for us. And of course, Christopherji, who's an encyclopedia on spectrum, and Brigadier Rawal. I enjoyed your presentation so much. I have taken notes, and actually I want to take a copy of this because I want to read all the books that you mentioned. But it's a very hard-hitting presentation if somebody really analyzes that and the amount of work that you put into bring it together in a very, very interesting format. And Ravi, of course, we have lived through this generation for the last 27 years in India, rolling out 2G to 5G. So my presentation number 1 is very colorful because this is the new Nokia, which is rebranded and it's got very vibrant colors. So I hope you will enjoy it. But what I will talk about is the discussion here is 6G. But I think all of us, to some extent, maybe understand what 6G is. But what I'll try to do here is, and I'm not an expert, okay? So I have also prepared myself for this talk because there is no expert right now on 6G because nobody knows what 6G is going to be. But I will try to say and do or show you the what, how, and when of 6G that is probably going to unfold in the next years to come. And before that, let's see what has been the evolution of networks. So we had the 2G and 3G networks, which were primarily connections. Okay, you first time got mobility, first time got a connection on your mobile phones, and we've seen that generation go through. Then came 4G, which was about information. It was about sharing. It was about data. It was about also unleashing social media. And then we got entrenched into, broad data and broadband becoming our lives. 5G, which is still being unrolled and unveiled in India, is what is being talked about as the next industrial revolution. So things like Industry 4.0 or many other related use cases is what 5G is perceived and hopefully will deliver in the next coming days as the use cases establish. But 6G is about this amalgamation of digital, physical, and human worlds. And I will explain this in the most simplified way that I understood to all of you in the next coming slides. So don't go with the language, but it's going to be an interesting thing of understanding what really it is meant by physical and human worlds coming together in a digital format. So this slide, I think all of us have seen for more than a decade. When I used to start marketing 5G and now 6G is coming, so I am doing my job here also. But when we started talking about this triangle, everybody knew, there was capacity, reliability, and scalability, millions of devices to be connected, huge capacity. And this was the promise, which to some extent is getting delivered by 5G. So we were talking about 20x traffic increase. We were talking about 100 Gbps of speed, 1 GB per user kind of throughput, milliseconds of latency, and then more than 10 million devices per square meter that could be connected or would be connected on 5G. And so this is till now. This is what 6G does, or it is envisaged or being researched to do, to add these 3 new dimensions to what we already have on 5G. Besides capacity, scale, and reliability, 6G promises to add sustainability, digital inclusion, and security and privacy as 3 key elements of what the networks of the future will deliver. Sustainability, I think there was a question in the last panel about it also, really what sustainability means. Yes, sustainability means reduction in carbon footprint, and it promises that 50% of energy consumption of networks will reduce, or at least the research is going in that direction as to how you can create more efficient networks. But sustainability is much more than that, I would say. Digital inclusion, and the digital inclusion in 6G, which is being researched, is about 3 key elements. It's about accessibility, affordability, and consumability. So now the whole vision of 6G and all the people who are talking about 6G are looking at how the networks can be cheaper, more accessible, and at the same time, develop use cases which will change lives for the future. And of course, security. I think Brigadier Rawal already mentioned that in his presentation. I've learned a lot in that presentation. Defending networks, the battle of the future is digital. I think these are things which at least there is a research or there is a discussion in 6G as to how these can be addressed with the new technology, which up till now, till 5G, to some extent have been there, but take it to a new paradigm shift. On the spectrum bands, I think a lot has been already said, but just to again give you an overview of different types of spectrum bands and how they are being consumed right now, and what is the potential of spectrum bands. And I'll not talk about all the technologies which are going on, but just specifically for 6G. And I know the challenges that the Brigadier Rawal brought out on the main 6G band, which is 7 to 15 gigahertz, which is being right now being discussed to be harmonized for 6G, or going beyond into the 92 to maybe 175, or even some people are saying 250 or 275 gigahertz, and a lower band, which is being also very actively discussed, which is this 470 to 694, which is, so in all new technologies, there is an endeavor to harmonize a low, mid, and the high band. And I think that's where, so I wouldn't spend too much time on this because this is a deliberation topic. And I think in the India 6G vision document, it is being discussed. And at the same time, there is a lot of discussion and debate happening on this. So what is 6G going to bring from a technology point of view? I told you those 3 dimensions of new dimensions, but besides these new tech dimensions, I think what is the constitution of 6G mainly going to be from is spectrum, more spectrum, and harmonized spectrum. Artificial intelligence, which was debated a lot and discussed in the last panel. Security, trust, privacy, we just talked about. Cognitive networks, architecture, again related to artificial intelligence and how networks of the future will become more cognitive. But I think there are 2 very interesting pillars in 6G, which I think you all probably need to understand, which is network as a sensor, and extreme connectivity. And I will spend maybe five or two minutes on both these discussion points. So what is network as a sensor? I don't know how many of you got a chance to visit Mobile World Congress in Barcelona. I know General Kocha was there and Ravi was there. And we did the first demo of a prototype 6G in our booth in Nokia. And what that demo was, I'll just explain to you. There was a wall, probably half the size of this wall, where there was a big panel of LED. And in that panel, there was a piano. And there was some hidden base station somewhere. Now, the use case was, and it was just a demonstration, was that when a person walks through that galley, that whole, you had created like a corridor kind of thing. When you walk through, there is no sensor on the floor, there is no sensor on the body. But as you walk through that corridor, you could play the keys of the piano as you walk. And you could go back and you could go forward and you could play the whole piano. So the is sensing you without you having any sensor, which is within you or within installed somewhere. So you become immersed as part of the network. And I have to read this because it's a great statement. 6G will give our networks the ability to sense. By bouncing signals of objects, networks will determine what's there, how things are moving. And the potential, even when they are made of, the networks become our sixth sense. And this is the promise, or this is the way 6G is being thought about. Extending our awareness beyond our immediate surroundings. The sensing capability can be used to map digital versions of physical world by interacting with the digital twin. So we can extend our senses to every point of the network. So there is this whole concept about metaverse and digital twin. And I think 6G is trying to bring that into reality, how you can get immersed in the network. So I think that is the big change from the current use of networks up to 5G and what 6G brings. So, I mean, if you start thinking about you being sensed in the network and the use cases, it's crazy. It's absolutely mind-blowing. It's something like science fiction, because tomorrow you could have in an old person having a sensor in his body, which the network is detecting, and if he falls, there is an alarm. So you, without really being, you could have a car, like we are talking about autonomous cars, but there could be hidden curves where you can't see anything, but a car is approaching and the network is able to sense an alert. So those are the kind of use cases. I mean, from defense point of view, you have a foggy environment and you know a battleship or somebody intruder is getting into your territory and you are able to sense it without having any sensor installed in that person, because that's the enemy for you, and take corrective action. So those are the kind of things which are being thought about in 6G, and it's fascinating and extremely, extremely interesting. And it can go on and on in terms of what 6G can deliver. The other thing which is also very interesting in 6G, which is probably not talked about here, is this ability of the network to what they call Network X. There's a terminology that we use in Nokia for 6G when it comes to. So we are saying that whatever a wired connection, the kind of latency, throughput, wire is always wire. It is point to point. It is very efficient. You cannot beat it. So can wireless become as good as a wired network? And if that happens, then you could have everything becoming so much more efficient. For instance, you could have robots in your factory, and if inside the robots you will still have a wired robot, right? Because his hands and his movement and his whatever he is doing it has to be wired, because you need that kind of latency. So if that can be executed without in a wireless fashion, you could have unlimited use cases of what. So this is what they are saying, and you could have smaller networks. It could be in this room. We know about private networks in 5G. but it is going beyond that because it will not have a correlation to the parent network, and it can have, you have millions and millions of smaller networks. 6G timelines, I think that was also already discussed by Isam, the HC, in terms of roadmap. But yeah, 2024, 2025, the first standards becoming a reality. Then by 2027, the first standard, so start work is 24, 25, 27, the first standards become a reality. And by 2030 is when we probably start seeing some real 6G deployments. So what is the key elements, in my opinion, from India perspective, what we need to be aware from a 6G success point of view? Spectrum, more spectrum, and harmonized spectrum. Collaboration, again, was discussed. Industry, academia, government, and various stakeholders who are there. Without this, I think India can play a bigger role because we missed the bus in standardization of 5G, and we may be much more. And the last, of course, is investment. There are countries who have already started and putting a lot of money on the table in order to take a lead. I think that is something that the government of India needs to also take a lead. It's not only the industry, it's not only a Nokia or Ericsson or a Reliance or a Airtel who can make this happen. It is a collective effort, and everybody needs to pitch in order to be able to create collaborations to make research happen. A lot of work is happening. We are part of all these developments in 6G, which are happening across the board. I won't go into details about that, but I think here from now to 2030, we have a huge opportunity. The 6G vision document is extremely a forward-looking thing. In fact, when I was talking to some of my global counterparts, they're saying that we first time seeing that India is taking a lead because this has not happened in many other countries. So with that, thank you very much, and hope there was some gyan.
Thank you, Anuji, for the colorful presentation. It's really colorful. Your logo looks beautiful. Ladies and gentlemen, now from the vendor, now we move to the operator. That is called Jio or Jinedo. So here he comes, our Ravi Gandhi, President and Chief of Public Policy, Regulatory at Reliance Jio.
Thank you, Shashi. Thanks, Amit, for taking us to the imaginative world or fantasy world. So while we were discussing, he was presenting 6G. It was looking like some sort of a fantasy world in which we are going to be while we are still rolling out 5G. We have now 7 years with us, because if 2030 is the launch of 5G, probably 6G, then we have 7 years. We can, I think, play good role in standardization, good role in, I think, spectrum management, good role in technology development, R&D, academia. I think this is the right time. Shashi, thanks for kicking this debate of 6G. And I think we as India should take the lead in 6G. In 5G, we have not missed the bus. We are there. I think India contributed in few standards, and we are rolling out as fast as any other country now. The road networks are rolled out. But when Amit was speaking, probably we forgot the use cases of 5G, which we are still waiting for to come. 5G is being rolled out, but I think the use cases, India has to still see the use cases for 5G. So few things which has changed from, say, 1G or 2G era to 6G era would be with every generation, the speed becomes 1,000 times. So from kilohertz to megahertz to gigahertz, and then TBPS, or sorry, GBPS to TBPS is the kind of speed which we think will be reaching. Whether humans can actually use that speed, even in 5G GBPS speed, probably humans cannot use that speed. So it's the machines who will be using that speed. And with machines, the humans will have to control the machines. With 6G, probably I think machines would be controlling machines, and we'll be sitting somewhere in between at the mercy of machines. So that's the kind of communication network which I see, and till 2030, many of us would be there, and I probably will see this live. Few things which have been raised by previous speakers is about spectrum harmonization, and many things. Probably yes, that the moment you talk about wireless network, the first thing which comes in mind is the spectrum, and more spectrum is required for more and more speed. Whatever bands you bring in, Mr. Christopher, all would be consumed in 5G and 6G. All mid-band and millimeter wave or higher band, etc. Few things which have happened and happening with technology development is we are no more the kind of traditional 2G kind of a network where you build in a macro cell and a lot of people are around it and covered by that. So the network would be different. Here, the network would go closer and closer to the consumers or customers where they are. It's more of a kind of a wireline network where you are actually putting the base station very, very close to the consumer with the higher speeds, higher frequency spectrum. That is one. Second is the traditional networks used to be called as like access network, backhaul network, etc. So that is, there won't be any difference between any access or backhaul. So access is backhaul and backhaul is access. So those are the kind of networks which would finally we will see the moment when we reach towards even in 5G also it has started all the integrated access and backhaul. The third is the cell sites will become very, very small and also become very, very large. So the cells would be a very micro small cell and also the satellite cells. So the one 5G network or one 6G network would be served from the small cell as well as from the cell which is floating around in the sky in the form of satellite. So this all would be integrated to one network with one user device. The user is able to move from one radio network to the other radio network to the third radio network seamlessly without the need of any change of device. So that's the kind of network where we are moving towards. And the moment we know what kind of technologies are going to come, how the networks are going to span around, probably I think the policy also need to factor in all those technological developments. Rest, I think on 6G, I don't have much to contribute at this moment of time because it's the vendors like Amit who have to develop technology and provide to the operators when it is matured so that it can be deployed for the consumers. As far as present networks are concerned, the 5G's network is being rolled out very, very fast, fastest amongst the world. And we expect that a lot of use cases, including the manufacturing use cases or so machine to machine or private network kind of a use cases would come in. While private network is a term which is very loosely used, there is nothing like private network. So earlier there used to be cloud over the network. Now it's a network over the cloud. So how can there be a private network over the cloud? And the cloud itself is a public cloud. So I think these are the kind of things, the technology is changing. So I think we also need to start thinking in a different way. Thank you. Thank you, everyone.
Thank you, sir. Thank you, Raviji. Now, the last speaker, before we have one or two panel, there will be a topic on panel discussion, which will be moderated by Wing Commander T. Yadav. We have the speaker from Madam Eva. Are you on the line? From
Yes,
Telefonica, Germany.
Yes, I am.
So over to you, Eva.
Good morning to everybody. It's a really pleasure to be with you and thank you very much for the invitation. Today I'm standing for my boss, Mr. Malik Rao, who is the CTIO of Telefonica Germany. For me, it was really inspiring to see that despite of geographical difference and possibly different regulatory and legal framework, the views when it on the 6G are quite similar. And I will in the first part maybe reflect what my colleagues were previously sharing. There was a question raised, is it now time to talk about 6G? If you look in the 5G and the presentation what was done today is that yes, we roll out 5G, yes, we are able to roll out faster than we done with the previous technologies, but still it takes much more time than we initially anticipate. Use cases were not ready. We were not ready as industry to support. Therefore, start talking about 6G 7 years prior we would like to be commercially ready is a proper time. Do we need one standard was another question raised in the round. And I do believe that we as industry have only one way forward, which is standardization, which is paying to us in efficiency and enabling us to provide more to our customer with less resources. Now, what we know in Telefonica Germany and what is our current standpoint when it comes to the 6G? We believe that 6G will become not only terrestrial stations, but also from the space and airborne network. We believe that networks will be based on the service-based architecture with disaggregated network components, with automation functions embedded AM and ML, both on the run side and the core side. And we do believe that application will and actively communicate with each other and with infrastructure directly in order to manage required resources. And most important, as being very active in GSMA association, we see network as a service, as initiative, which is actually helping us to set the pace toward the infrastructure which we will need on the end of this decade. Network as a service is actually ability to expose capabilities of our network on automated manner, introducing the network-wide slicing and edge compute, and improvement of it brings improvement of the great automatization in the networks management and orchestration. Now, what is the position of Europe when it comes to the 6G? So the first, it was, I think, mentioned by the first speaker, there is European Union is funding 6G research project under the umbrella Horizon Europe by 250 million until 2025. And the focus is on the smart networks and services. Going one level, in the German federal government already put 700 million funds in order to do the proper research and development on the 5G networks and services from the perspective of innovations for the end user. Optimizing processes, enable digital twinning, data analytics, but last but not least, also ensure upskilling of personnels in the companies and enterprises. All of these activities in Germany are within the two programs centralized. One is called 6G platforms, and the second one is called 6G NN. Telefonica Germany contribute actively to this 6G platform program, which is run by Federal Ministry of Education and Research and has a very high social relevance. The program ensures that non-telco industries can contribute into the 6G leading applications and the requirements, plus enable harmonization across all active research projects by 6G. On the end, I will mention one more activities, what we are actively driving within the Telefonica group, as we do believe that as I already mentioned, that in the 6G, it's not going to be only about territorial, but also from space and airborne network. Therefore, we set up the program, which is called 6G Takeoff, where we are researching network and service architecture for the non-terrestrial networks. We focusing on enabling seamless integration of space and airborne infrastructure. With this, I will pause. Once again, thank you for the opportunity to at least briefly share you the perspective from Europe/Germany/Telefonica.
Thank you, Ms. Eva, for your kind words on the 6G. Thank you so much for giving the input. So now I hand over the mic to Dua Saab for moderating the 10 minutes on the 6G topic. As General Kocher said that he will answer only in the panel discussion on 6G. So over to you, Dua Saab.
Thank you very much. Having heard the eminent speakers addressing spectrum, global standards, and many more issues in 5G. Most heartening to listen to was Brigadier Rawal. It looks like that the military application and usage of this, they are far ahead of the curve, I think. Thank you so much for giving us insight into that. Thank you. Now we heard about many things about this. I got just 2-3 things which I just want to leave it to my eminent speakers. One is the energy part of it, and the second is the security, and the third one is the interoperability part. Now, as you expect that the 6G is expected to have significantly higher data rates than 5G, which would mean energy which is much more required than the 5G. On the security side, again, while with the increasing number of the connected devices and the growing importance of data, security will be a major concern for the city. And lastly, the third issue, which I leave it to my eminent panelist, the interoperability. With the growing number of wireless technology, will it be important for 6G to be interoperable? As I am informed by Shashi, can I hand over to General Co-Chair to address one of the issues at least, whether energy, security, or interoperability?
Thank you so much, Mr. Dua. See, security has always been a concern. Now, I will step back a little bit and see the evolution of networks. If you see, when we were in 2G, we had one-to-one communications only, and that was limited to the device. We went from there to 3G. We got internet in our device. So apps started coming in. So that made a huge difference. And we could increase the speed at which we could communicate with others. And we started using data to communicate. Went into 4G, there was an enhancement of what 3G brought to us. And in 3G, we were thinking with the cap of 2G and planning 3G networks. Hence, 3G didn't last too long. We went into 4G, and that is where actually we started using internet in our hands. Come to 5G, a new generation is coming, where we have flexibility, adaptability. Machines are talking to humans, humans are talking to machines. So a lot of flexibility has come in, and the network has expanded. Network is now partly in your pocket as part of your device, right? Coming to 6G thereafter, it'll be an enhancement, very much like what 3G to 4G, from 5G to 6G. This is the way I look at it. The difference between the two is that there are no fixed boundaries of networks in 5G and 6G. They are expanding, contracting as the situation demands. And therefore, the old method of providing security as an overlay to networks, we were up to 4G. We knew the parameters. We knew these are the technical parameters in which the network is going to function. We knew the capacities of the networks, and the flexibility had to be manipulated manually or automated, but it took time. Now it will be instantaneous in real time. 5G will be able to give what the user wants. Now, with this expanding and counteracting network, if we continue providing security in the manner which we are used to, of creating security layers and then overlaying it and integrating it with the network, that may not work. The reason why I'm saying that is security has to be of the same caliber and of the same genre of what it is protecting. If you overlay a security layer, which at times is larger than what it is protecting, and at times it is smaller than what it is protecting, it will not work. Second reason is, with these networks, with 5G and 6G networks, the input vectors are all attack vectors. A small sensor in the part of which is attached to a network is as major a challenge to the network as a human being is, or as the core is. So the attack vectors are going to be humongously increased. So with all these parameters put into place, and 6G is going to see even much more than that. With all these things put into place, we are also saddled with a problem that to achieve flexibility and adaptability, we are increasingly dependent on software, including AI. So the entire network now depends majorly on software, which itself is susceptible to security breaches. At this point of time, we think of application security, we think of network security, we think of data security. I think this is something we have to change. We have to go into end-to-end security. And to provide end-to-end security, we will have to build security into the systems right from the drawing board. Maybe industries may have to merge. Maybe the telecom manufacturers and the IT security guys will have to sit together along with businesses and decide what type of security is going to come into play. There's a new paradigm of security that we are going to see, and the sooner we realize this, the better it is. We cannot sit tight wearing a 4G cap and plan 5G networks or 6G networks. We have to get rid of that cap. Fortunately, we have started moving in that direction, but all the applications that people have been talking about are easily met by 4G also. So where is that killer app which is native to 5G? That is something which will come if we wear a 5G cap. And that is something we have to wear not only for network planning, but also for security planning, right from the drawing board upwards. Thank you.
Thank you very much, Coach Saab. Due to the paucity of time, I'll just request each one of my speakers to just say in 1 minute whatever you feel like to say on the energy, security, interoperability, so that we wrap up this. Over to Ravi. You have just 30 seconds. Your time starts now.
Digital inclusion. I think one dimension which has been added, I don't know what the purpose of that is, but digital inclusion.
Thank you. Over to Brigadier Rawal.
With the time limit given, I have only one point. When we were in the academy, they said, as a junior, 2 rules apply. Rule number 1, the boss is always right. Rule number 2, rule number 1 refers. So my boss has already told something about security. I cannot differ on that.
Thank you so much. Over to Christopher.
Yeah, security is one of the cornerstones that is being devised under 6G. I mean, whatever has been shown here already, that factor I think is already there into that system. That is as far as my understanding is.
Yeah, Amit.
I've already said a lot, but I think collaboration, harmonization, and above all, support from government can only make 6G happen. You have heard 700 million, 500 million, 1 billion government spending. I mean, without research and that kind of effort to be given, I think we need to do a lot.
Thank you, Amit. We have our friends from ETSI and Telefonica. Let me just ask ETSI, as it looks like, as I heard, is 3GPP and ETSI seems to be very neutral on the standards for 6G. What are your views and when do you see this standard coming out? By the 5G, we have no single standard available. Over to you.
Yes, as you rightly mentioned, we are quite neutral. We have a very diverse membership whenever it comes to ETSI or 3GPP coming from the different regions, from the different industries. So this is, I would say, a very natural position to have is to be completely neutral and let the standards making be industry driven and contribution driven. The standards are made to answer industry needs, customer needs. So it is not up to the standardization organizations to define what 6G should look like or the timeline. This should be definitely driven by the industry and by the market. The market dictates when the needs are there, what are the use cases that we need to answer to, and what the industry and operators needs and are. So we have been very neutral in the 5G. And all previous generations, actually, it's not only all the standard makings. We have been very neutral on this. When it comes to the 6G, I just want to go back to the last slide I presented and the need for having a one global standard for the 6G. What made 5G a success, in my opinion, is the fact that we have one global standard. And this is one thing in the 3 points you mentioned, interoperability is key. And to have interoperability, standard is also key, and having one global solution is definitely key. Thank you.
Thank you very much. Now I'll request Madam from Telefonica. As usual, the women have always the last word. So I hand over to you to give the last word. Thank you so much.
Thank you. Thank you for the last word. I will address intercomparability between different generations and would urge all of us to think carefully, do we need it and what we need it. In Telefonica Germany, we already successfully retired 3G network, and we are currently all
Yes, madam, continue. Got disconnected? Yeah, she's back. Yes, continue, madam.
Hi, sorry. I don't know what is the last thing what you heard, but the message which I would like also to pose is that we need as industry also to focus on retirement of the technologies. And I'm happy to say that in Germany, we already managed 3G and we are currently dealing with 2G. And with that, we can also have additional resources in order to launch new technologies in the spectrum, but also we can support sustainability of the solutions which we are having in our landscape. Yeah. So thank you very much for opportunity to talk. Yeah?
Thank you. Thank you, madam. Thank you. So we come to the end of the inaugural session. So what I can hear from the top panelists, that spectrum, and the ecosystem. You know, the entire ecosystem has to come together to have a 6G, not like 5G we rolled out very fast, but Jio still rolling out as per Reviji. So 6G, we have enough time to discuss the entire ecosystem to come up with the launch of 6G.
Thank you, ladies and gentlemen. I will request the chair, the guest of honor, Christopher sir, to present the mementos to the distinguished panelists. First to Reviji. Come to the center, sir. Yeah. Thank you. Thank you to both of you. Thank you. Thank you, sir. Thank you. Then to General Kocher. Brigadier Sanjay Rawal. Dr. Isan, I will send your memento when Dinesh comes to ITSI headquarters. To Amit Marwa. Dua sir. I request General Kocher and TR Dua together, Sri TR Dua together to present the memento to Christopher sir. Thank you, ladies and gentlemen. We'll have a lunch 1 hour and we'll join back exact at 2:15. Thank you.
Because connections are what make us human. Communication unites. Cinemas, the world's most connected company.
On 6G, Ultra Wireless Communications research for a new generation of mobile wireless communications started more than 10 years ahead of initial. Launching 6G in 2030 means research and 6G
seats.
And will require changing how networks operate. Delivering 6G demands significant advances in computing and networking architectures, chipset designs, radios, antennas, and materials.
Good afternoon. May I request all the delegates, please take your seats.
And connectivity challenges. Extreme modulation bandwidths and shorter wavelengths will reduce beam width and increase antenna and device integration. Radio resource optimization and intelligent networking will also require innovation in RF, baseband, and system design. Significant technical challenges are on the horizon for wireless design and test engineers. While continuing to enable 5G development and deployment, Keysight is also active in 6G programs around the globe, working on solutions for the 2030 wireless era. Our current solutions provide advanced capabilities that test far beyond 5G. With Keysight, you can build 5G today while preparing for 6G tomorrow. Explore your options today.
Today, our future is a vision.
Once again, may I request all of you to please take your seats. Networks, 5G evaluation and 6G. AI-powered network automation, 5G and beyond, transforming industry and enterprise with 5G and beyond. This is the theme of the technical session. The session will be chaired by Mr. Jeevan Talgaonkar, Vice President and Head of 5G Solution, Reliance Jio. May I request Jeevan to come on the stage? The special address is by Shri A. Robert Ravi, Chief Technology Officer, Government of Tamil Nadu. May I request Shri Robert Ravi to join us? I am sure all of you know Robert Ji. He was in TRI before he moving to Tamil Nadu, and soon we hope to see him in Delhi soon. I request Mr. TV Sriram, Global Head Network Operations and Accenture. TV? Yes, here. Satish K, Head of Standardization Asia Pac Nokia. Yes, Satish, yeah. Alka will be joining in some time, that's what she said. Yes. So this is the panel on the technical session. So now I invite Shri A. Robert Ravi to give his presentation, and then I request the chairman of the session to after Robert Ji gives his presentation, it's all yours. Thank you.
Good afternoon, ladies and gentlemen. It's a pleasure to be around for the 5G. When we are talking about 5G now, we are talking going a step ahead 6G. What I'm trying to do in the next few minutes, maybe the next 10-15 minutes, to take you around what are the opportunities that are around 6G and what is going to be the power of 6G, these opportunities, challenges, and how it's going to impact our life. We know there's going to be a lot of discussions on the applications. The applications are all emerging. People were talking about killer application. To put very short, 5G talked about integration and interconnection of man, machine, and object. 6G takes one step further to add the gene also. So which means you're going to go in a complete virtual environment. That's going to be the reality. So which means you're going to have a XR, VR in a real-time world. So your phones and other things is going to take a next level of change where you're going to have a complete immersive experience. The 2D calls which you are having today, the calls what we make, they're all called 2D calls. So because they're two-dimensional one, it's going to be replaced by what we call as 3D calls, the holograph communication. We are going to see all the connected robotics that's going to happen. The complete utilization itself is going to see change happening. Most interestingly, we have been talking about this BrainNet for quite some years now. Now the vision of this BrainNet is going to be a realization. So we are going to actually bring in BrainNet and solutions surrounding it, because 6G is going to drive towards what we had, connected devices to connected intelligence. It's going to be a complete intelligent network, which is on its own. We'll be seeing some of the slides on it. And we are going to drive, especially in the nano and the bio-nano stuffs. What we have been talking about, Internet of Things, is going to go to the next level of Internet of Nano Things. We are talking about Internet of Bio-Nano Things. That's going to be the new era. From the perspective of the customer, we are going to experience what we have, a complete metaverse environment. The way of life, what we have, is completely going to have a complete sea change in the next few years. Education sector, we are going to talk about immersive education, which means as a student, her child goes on reading through the sensor network. I think the speakers were talking about one of the key elements in the 6G is going to be the sensors, network sensors. We'll be able to identify what is the extent to which the child is learning, and then accordingly the teachers or the course correction happens. So that's what it's going to be, a complete sea change in the education sector. Similarly on the agriculture, everywhere we are going to see different, we are going to talk about the real digital agriculture coming in also. As far as the telecommuting, we know because of COVID, we had a lot of issues of this video conferencing. Though we went into this video conferencing era, still the personal touch was always a problem. This is going to be solved in 6G, where we're going to have a complete telecommuting, where you'll have a holographic thing. Somebody comes and sits in front, and then you start chatting, and it will be a real feel. Of course, the entire roadmap of what the network should look like has already been defined in 2020 by ITU's focus group. So that is going to be the base on which the 6G itself is going to revolve on its own. We're going to talk real intelligent cities. The word of smart is completely going to be eliminated into what we call intelligent. We're going to have intelligent cities, intelligent environment, intelligent, everything is going to be intelligent, because it's going to be a real marriage of AI into the networking sphere itself. And we can keep on talking about the different applications, like I mentioned about the BrainNet. So the brain-to-brain communications, when it happens, is going to really revolutionize the next Web3. Web3 is going to come in, then it's going to be a conversational image. The sensors is going to be, and human interaction is going to be at a different level, where only by gestures you will be able to communicate to anyone, even devices, etc. And be it for your health, or it could be education, or for health, entertainment, all these purposes, brain communication is going to play a real big role. Another very, very interesting thing which is going to happen is people were talking about security, how secure is the data, everything. The concept of blockchain itself is now going to move into the network, as we can see in the figure, starting from the infrastructure, even your spectrum sharing, everything is going to be on a blockchain-based driven infrastructure. You're moving the blockchain to the edges, to the core. You're going to have an overlay network for the service sector, and we have a core network on blockchain. So the entire thing is going to be distributed ledger technology, which is going to run on as the base of the 6G. Most interestingly, what is happening in the bio is, the biosphere, everything is going to what we call nano, which means we are going to have nano robotics, which is going to go into our body, which we can feel and add the sensors. So probably you'll have your pulse oximeter nanosensor, or blood pressure nanosensor, ECG nanosensor. This brings out what we call Internet of Bio things. That's another field which is coming up. And everything is going to go on a pervasive nano things. That is another key driving application that is going to drive into the 6G. The urban space itself is going to completely go into different. People are talking about e-commerce sites where today we go and purchase this item. This entire step is going to change what we're going to have, a digital twin space, where you'll be able to feel, look, feel, and sense the object before you buy. So maybe in your physical shopping mall, or your product details, or a communication with the customer, everything will go into a complete digital sphere, where you'll have a digital replica made, and the sense of touch and feel also is being inbuilt into it. That's going to be the driving application that's really going to come in. Another very, very interesting thing that's going to happen in 6G is going to be the federated learning. Morning, people were talking about how my data is secure, where the data is going to be there. The concept of the machine learning, which was a big data analytic itself, is completely moving today. Today, when the concentrated amount of data, because when you do a machine learning analysis, all the data needs to come to a common place. When the data comes to a common place, the data analysis happens. How are we going to do that? That we're going to do away with what we have. Different types of machine learning is going to come, including quantum machine learning. But the key base of it is going to be federated learning. And this has been already approved. I know in your release, somebody with the latest 3GPP has already approved this for 5G itself. So this is going to be a base on which your networks is going to be built. So where you can see, if you can have a look, you can see in the edge, every device, whatever device we have, itself acts as a database. And these database, your data, the actual data is not shared. The privacy data is always stored in your device. It is anonymized, and this data will be having a small model kept at each of the device. Each device has a simple model, and then you will have an aggregator model, then you will have a global model. So the entire concept of machine learning itself will go for a toss, and where all your protection of your security, private, everything is properly in place. We have a vision in Tamil Nadu. We call it digital TN. We have already started working on it. It's a 5G, where what we think and dream is a collector, district collector in his district, you should have an intelligent display where you should be able to get data about everything in his district. For example, how much is today's my GST sales? How much fertilizer has been used in the district? What is the number of trucks moving in, moving out, temperature, weather pattern? Is there any commodity is going to happen? Using CCTVs, we can even do a predictive analysis. Any commotion is going to happen. So all this sort of a digital TN, which vision we have, we have started building it in 5G today, which I'm sure will go on an immersive virtual way when 6G comes. For example, on the mobility side, we have the road data, vehicles data, traffic data going in. On the health side, personal data, hospital statistics. Even we can see why a particular medicine is more used in a particular area. Is there any particular disease in that particular area? Outbreak of any disease. All this could be very clearly understood. Infrastructure side, the buildings, the airports, commerce, as I told you, even we will be able to track the amount of taxation that is happening. How much tax are you collected today? That information is available. In education side, agriculture, of course, agriculture, as you mentioned, we are going into what we have, digital agriculture. We talked about precision agriculture, etc. But we are going to put a real use of this. For example, a satellite map will be continuously monitoring a field of agriculture. If it can detect any locust or any insect, send in information to a common database. This database triggers the nearest BTS. Through some sensors, the drones will be activated. Then probably pesticides, control, and a photograph of the confirmation. Everything happens automatically. There's no human intervention at all. This is what the vision has been dreamt of in 6G. Of course, with this application, what are the key driving trends? Now, as we know that we have always a spectrum problem, the spectrum reliability is going to increase, and we have to pack more number of bits together. What is going to be the technology behind it? Now, we have been talking about, I'm sure you know about aerial thing. We are going to move from aerial to volumetric, which means bits per second per hertz per square meter, which we are talking about. Now we are talking about bits per second per hertz per cubic meter. That's in volumetric. That's going to be the sea change we are going to have. And we are talking about, for this amount of application, two very essential things are very, very important. One, the speed, which people have been talking from the morning. So at least you should need a peak data speed of 1 TB. And at least the user end, it should have at least 1 GB. So that's the speed we're thinking. And most importantly, latency. In 5G, the latency should be much more better than latency. Because in 5G, if you are trying to do a remote surgery or a more autonomous driving, the amount of reactive time should be very, very, very less. It should be in millisecond or microsecond. That's not presently available in 5G. So that 6G should be in microsecond. If you talk about the seaplane, it's going to be 0.1 millisecond, or it's the U-plane, it's going to be at least 1 millisecond. So that is the amount of stuff we are thinking. And moreover, the mobility, the speed should be around 1,000. Number of devices that is going to connect is going to be 10 power 7. Most interesting thing is on the efficiency, energy efficiency. We'll come back to that in subsequent slides where we talk about the new concept of energy harvesting is coming. So no longer the devices, IoT devices. Just imagine you're going to have billions of devices put everywhere because it's going to be a man-machine object gene working together in a 6G environment. Billions and billions of devices. You can't afford latency. You can't afford speed problems. So to take care of this, and the most important is your power. So we are going into what we call battery-free environment of energy harvesting techniques for these devices. This is another new area of research that is coming up. So that is, and another thing very important is the emergence of smart environment. We are now talking about smart environment, smart surfaces. And what are these intelligent surfaces? They are nothing but RIS. They are nothing but a reflective intelligent surfaces. What happens is, today, we have a lot of antennas available everywhere. So the cell structure is designed. You have a tower in the center of a cell, and then you have the inter-cell problems, issues all available. This is completely go away in 6G. 6G is going to think about a cell-free MIMO technology where everything is everywhere. And most interestingly, every device will have a separate antenna. That's one of the research going on. So if you say n number of antennas, k number of users, n is going to be greater than k. That's the vision which we have been thinking on 6G, which means the technology, the modulation, the multiplexing pattern, everything is going to change. Of course, we are going to be the SDM, the space division multiplexing, but an advanced version of NOMA going to come in. These reflective intelligent surfaces could tune the range of frequencies, whatever is available. And the research is going on in a number of ways. They're very simple. They can be made as a paint. You can paint a building, paint a glass, or paint your surfaces, any of these surfaces, which will act itself as an antenna for your services. And they consume little amount of power. It's a research on its own. So we are talking about such smart environments, smart intelligent services coming up in a big way. All of us know that in 5G, we've been talking about SON, the self-organizing networks. Now the SON is going for a toss. Now we're going to talk about self-sustaining networks. So the networks itself will become intelligent. It itself will allot its required computational resources. Whatever resources allotted, intelligently allots, and the network sustains on it. Suppose there is going to be a outage in one one of the towers, automatically the payload of the other one is increased or decreased to ensure you have a complete ubiquitous connectivity. More interestingly, what is going to happen is it's going to be a complete convergence of communication, sensing, control, localization, and computing. Localization will be up to some centimeters, and network sensing will be discussed at length. And the last thing very important is all your smartphones it is going to be on a dying era. You're going to have what we call intelligent phones. These intelligent phones itself will be so intelligent that they automatically talk. Suppose there's an issue, similar to a wearable devices. Some issue with your health, these intelligent devices can talk to the hospital, get the information, even trigger ambulances on its own. The sky is the limit of the sensors, what is going to happen. So we are moving into a complete intelligent era. Going into the three essence thing which we talked about, the network sensing, the connected intelligence, the application scenarios are different. So now with the AI put into being, so the AI native communication is going to come in. That's a create very essential. The AI native communication, it has its own transmitters, and it will have its own receivers. Now, more importantly, we are moving into what we call a haptic communication. Now, you know that when I was talking about in the first session, I was mentioning that it's going to become a marriage of man, object, machine, and gene. The most important gene function is nothing but is semantic communication. So the communication itself takes a different sphere. That is what we are trying to go into the AI native communication side. Network sensing, I think I was already mentioned, you'll be able to sense that you're available without any sensors available to your body. That's how the system works. As you mentioned, the localization takes up to a few centimeters, the calculation that is possible. And the entire thing is connected on an intelligent platform. So that's what we call connected intelligence. Of course, the intelligence also moves to the edge. We'll come to the next. So that is what we call the edge AI. That is empowering your AI. So the intelligence actually happens in the devices, the edges, and then it goes to the core. So that gives you various rise of applications which we mentioned earlier. Let us see what are the enabling technologies. When you have these enabling technologies, of course, we need to have continuous area of say 90G. So one area, I think morning, a lot of spectrum discussions happened in. Probably we need to have a terabit per second, means probably we should be even large frequency. Very interestingly, these transmitters, which have been designed, role, the network service provider's role, everything is going to have a sea change in years to come. I just mentioned about the edge AI also. Another very, very important, of course, the earlier sessions, somebody touched upon it, was ubiquitous connectivity, which is across all, not only for terrestrial. It could be airborne, satellite, or underground. So it will be ubiquitous connectivity. That is going to be the key. And to all drive this, a bit of quantum is also required, because when we talk about the security of the area, though we build in a lot of network security, we need to go on quantum cryptography, quantum enabled machine learning. So quantum computing is going to come in a big way. So this new technologies are all going to be these enabling technologies. To put it in short, what is happening in, I'm very sure all of you are familiar with this triangle, the EMM, MTCs, and the URLCs. Now, these define what are the services, right? From 3D videos to your self-driving cars, to gigabyte in a second. But now what is happening, of course, instead of directly going to a 6G, there's something called a 5.5G. Of course, different people like Huawei come up with this vision. What they try to do is something for the uploading of your HD. So something was introduced, upload control broadband communication, that UCBC was introduced between EMM and MTC. That was a small triangle which we have brought in. And the other one was on the real-time broadband communication. That was another thing. These two came up. Apart from it, on the user side, a small bit of human interference, that is human-centric services. All the human-centric services came in. That is the HCS. That was the 5.5 if you keep it. The real 6G vision is going to be an extended version of this EMM. So with the cognitive agile EMM, that's what we call it. The real-time broadband. This is going to be extended one. Of course, on the URLC, we are going to go, lot of devices going to add density. So we are talking about extended density URLCC. That's going to be an extension of it with human-centric services. Of course, on the MTC, you're going to see the UCBC and the COC, computer-aided oriented communication. That's another step is going. This is going to really bring in various services, as we mentioned, federated learning, AI, network, industrial 4.0, etc. The key thing is this triangle will slowly go into what we have a complete sea change on new media, new service, new infrastructure. That's what we talk about. We were talking about security in the morning. For that, the infrastructure, the new infrastructure builds in something called trustable infrastructure. So you build the infrastructure itself as trustable infrastructure with federated network and a complete integrated terrestrial communication, which I mentioned between terrestrial and the satellite, the airborne stuff. More interestingly, they are even planning to bring in drone BTSs, flying BTS. That is what we call flying BTSs, which will be ensured, because you can't have any single point without any coverage available. So in a 6G, it should be a complete coverage, carpet coverage. To achieve this, different types of technologies need to build in. Of course, the new media, it could be wearable glasses, as I mentioned. The smartphone era will slowly die down, and everything is going to be using smart, maybe glasses or shoes or watches or tabs, all intelligent devices connecting together. And on the media side, it will all be virtual. Your education, your painting, tourism, everything becomes virtual with a real new infrastructure coming into place. That brings into what we have the three key important connectivity. That is what we call the sagging networks. As I told you this, when you have this ubiquitous connectivity, your surface, air, and ground information network will become a reality. That's what we call the sagging networks. That's becoming a reality in 6G. And everything is going to be intelligent, as you mentioned. It's going to be completely intelligent, very important, controllable. Every device. Suppose you have an RIS painted on your wall. These wall devices also could be all controlled using an RIS controller. The RIS controller will trigger which particular device is which antenna. So every antenna of every user to any antenna is easily controlled using an RIS controller. So that is what we are thinking in an RIS assisted system. We are talking about holographic communication. We are talking about deep connectivity. All this is all possible with the advancement in technology, what we think about. So to put it in a nutshell, these are the various dots of the technology that is all evolving. Concept of everything connected to a network, everything as a service. Semantic communication, augmentation of human intelligence. The backscatter communication, which was already there in 5G, itself is now going to be used in a better way for communication. That's another one. Of course, the human-centric wave framework. We are most importantly, the quantum also comes into with QC-assisted communication. That's another area of research going on. The spectrum, I have just mentioned, any range of spectrum could be used in any devices. We are not going to be having any spectrum sensing. So a new technique for spectrum sensing is coming into being, be it blind detection, eigenvalue, cyclostationary. These are different technological advancement that is happening. We are slowly moving into what we call time convergence. Everything is converged into a common family, what we call the time convergence. We have the quantum artificial neural networks coming in. The sixth sense, when all this comes in, you're going to be intelligent network. It's completely, that's what we call, can we develop what we call a sixth sense communication network? That's another area of research. So it's a complete AI solution with intelligent cognitive self-sustaining networks. We were talking about QoS earlier, quality of service. Then slowly we came about different types of the quality of service variants. Now we are going to talk about quality of life as a parameter for these services. So QoL, that is run on what we call generative adversarial networks. So as you can see, you have new technologies going to come in and really do a thing. As far as the infrastructure is concerned, new infra with infrastructure, with fusion infra, innovation infra, integrating ground, UAV and satellite is going to be the real game changer. And another very interesting thing of the entire stuff is two very important technologies. Fluid cells and fluid antennas. Let me come back to this. With this, the driving applications drive the trends, and the trends are driving the various enabling technologies. One of the research paper, of course, puts and predicts 6G as this graph. Very, very interesting graph, very lot of data available. I was mentioning about fluid cells. Fluid cells are any BTS automatically depending upon the load capacity could change its altitude, its information. So they are become fluid. That's a new technology. Cells are becoming fluid cells. Fluid antennas, very, very interesting research going on. Any antenna through a type of fluid material like mercury will be able to tune up to a particular spectral wavelength in the transmitter. We talked about the integrated frequency band transmitters, which use fluid antennas. It could be ST fluid antennas. So as we can see on the right-hand side, you can even start from your body area network, sensors, massive information, gateways, completely. On the other side, we have the reflective intelligent surfaces, even your walls, large intelligent surfaces could also act as a wall. Device to device, fluid cells, vehicle to vehicle, and it will be complete integration. You can see on the left-hand side, from your underground, that is from your submarine to your space shuttle, you'll have all the interconnectivity happening smooth, true broadband speeds. So in short, massive IoT, massive MIMO, tiny cells, cell-free, fluid cells, wave, multi-terahertz, visual light communications, another very new concept is coming for the smart homes. If you can see the figure inside the smart homes, it is all similar to Wi-Fi. We have the VLC in a very big way coming up. Fluid antennas, large intelligent surfaces, vehicle to vehicle, device to device, NOMA, intelligent caching. Caching is intelligent. Energy harvesting, as I mentioned, the devices will become intelligent, it can do harvesting. Wireless backhaul and an integration of all these satellites, which will actually drive the entire quantum system. Of course, this is a rosy picture of what is going to happen in the 6G we have projected. Each one of these technologies are having a problem and research is going on. I wish each one on this room to at least go back with one or two of these technologies and see how we can take this forward from the Indian perspective. Let us take the terahertz band communication. We need to have this fabrication testing of antennas, real-time control algorithms, communication protocol coordination is an issue. I was talking to you about intelligent communication environment, the surfaces. You need to see the trade-off between the dimension and the energy consumption, the compatibility, standardization, how we are going to use it for the existing environment, how we are going to introduce AI-driven. These are some of the open problems. And the AI, the pervasive, we are going to talk about the pervasive AI. Well, what is the generalized algorithms we need to use? What are the effective comparison metrics that we need to bring in? How the network should be automated? What should be the accurate intent that is required? We talked about reconfigurable transceivers. Of course, it's a very novel design, but this design will have all spectrum communication. How do you do this reprogrammable circuitry? How the interconnects will happen? What are the type of antenna? They require novel integration and real packaging techniques, because you have to pack number of devices in over a small 1 square centimeter of area. And the backscatter communication is going to have a real spectrum and energy efficient thing, which we talk about. And of course, we talked about the Internet of Space things, combining all the ambiguous connectivity, how we are going to design a multi-band transceiver that is going to take care from satellite down to submarine. Low, but it should also be low latency, because immediately it should have a reference, low latency, high speed. How are you going to hand over it? And of course, we talked about the cell-free MIMO, because no longer the honeycomb cells are going to disappear. We're going to go into what we call a cell-free MIMO environment. For that, how are you going to use the user scheduling? How are you going to do the optimization of the APs? Because you know that in any room, I told every antenna is going to be on a user. You're going to have N greater than K. So how particular AP will take a particular antenna, that requires real optimization techniques, Internet of Nano Things, the power efficiency model, biothings, quantum communication. Quantum communication, we talk big, but the very, very key thing is your quantum error correction. The moment the quantum computing happens very, very fast, but the problem of quantum error correction really takes over. For example, to do one calculation, you need to do X amount of computation to have the end quantum error corrected. How are you going to balance it? These are some of the open problems. If these problems are being completely rated, we can have a clear vision, 6G, what I talked about, in reality. I'm sure you should be ignited of these opportunities that are available. Let us take back one of these areas, and I'm sure we should start working on these areas to make 6G a reality. Thank you.
Good afternoon, all. First of all, I would like to thank Sri A. Robert for such a nice 360-degree view of 6G technology. And this reminds me of a book, Homo Deus, if at all you had read it. It's from Yuval Noah Harari. He's one who throws a lot of ideas. When I looked at the plethora of 6G applications which were cited by Sri Robert, it reminded me of the writings of Harari. So thank you very much. And this is no surprise, because whatever little I understand of Indian market, I had seen with respect to 5G adoption that the government is at the forefront compared to the private industry. There are many PSUs who are seeking 5G. They have a budget to create the test beds. They have the budget to roll out 5G in an actual commercial environment. Let me give a few of the cases where we clearly see 5G taking off. Because to talk about 6G without touching upon the very substrate of 5G, which is pretty new in India, I think it would be like being very off ground, and I don't prefer that. And our event organizer today, he asked me to touch upon a few of the 5G use cases. And one of the uniqueness of Shashi is that he always puts the speakers in a very odd spot, primarily because he picks up very future-centered topics. So thank you very much for making us read a lot before coming here. So there are a few 5G use cases which are really taking off in India and commercially taking off, let me tell you that. So one of the use cases is using 5G technology as a fallback option to existing SD-WAN network. I'd clearly seen that most of the manufacturing companies, they have MPLS as kind of powering their SD-WAN network today. But what if the primary link of the MPLS goes down? Then they're looking at 5G as a fallback option. And that's where we clearly see an opportunity to monetize 5G today using the fiber and using the 5G front haul. There are a few other manufacturing companies, and why manufacturing I'm saying again and again, primarily because India has 18% contribution to the GDP coming in from manufacturing sector. So it is very obvious that that is the sector which will throw a lot of challenges to us and also will throw a lot of ideas to us being a telecom operator. And they would ask us to design the use cases for them to be monetized. One of the things which I see still in a test bed is autonomous vehicles. And that is a future use case for 6G, sorry. Because the kind of latency and the throughput that it requires is not likely to be served by 5G today. So, but the use cases which are dominantly been exploited on 5G is robotics. And Jio had actually foreseen the potential of robotics much ahead. And that's one of the reasons that we acquired a company called Adverb. Earlier, the telcos were of the mindset that we would not go ahead and invest ourselves into making the use cases. But if you want 5G to take off, there is no other alternative. You've got to invest in the use cases. So the robotic company was taken over. And now what is happening, is that we are putting a 5G modem inside the PC of the robot. Then I just have to embed a SIM card as an auxiliary unit into the robot and it starts working. That's it. So it becomes very, very easy as a telco to power up the robot using 5G. Otherwise, you need to carry a big modem, take it closer to the robot, keep it on the top of the robot. And you'd not believe in a manufacturing environment, there are hundreds of robots running on the same floor. So if I carry 100 auxiliary units of the 5G modems, which are half the size of the robots, nobody's going to accept it commercially. So you've got to really get inside that equipment to make sure that it becomes 5G ready. And that is an effort. And we are taking that effort to make sure that the entire ecosystem comes to life so that it becomes embraceable. Let me give another example of the AR glasses or the VR glasses. It's very easy to talk about it, right? AR and VR. But to make one use case come to life, it takes your blood and sweat. And we have acquired a company called, I forgot the name of the erstwhile company, but now it's called GeoGlass. And it helps us do the augmented reality. And we've been putting straightway a 5G SIM card inside the goggles so that it comes to life. And I'm able to inspect the digital model of the equipment or whatever is running in a manufacturing setup using the glasses so that I'm able to figure out if at all there is any anomaly with respect to its physical design. And I'm only able to fix that anomaly as a quality engineer. It's helping really on ground. With investments being made into the MEO and the LEO orbits for the satellite communication, I think that's going to be handy for the 6G as it evolves. Finally, let me just give few differentials with respect to 5G and 6G. What is it that's going to be very different with 6G, which is not there with 5G to be offered? I think even after having secured the best of the spectrum assets available in India, 1000 megahertz of midband and 1000 megahertz of high band and 100 megahertz of midband and 10 megahertz of low band, we are able to give 1 Gbps throughput on a midband, 1 Gbps on a midband, right? So what happens is with a millimeter wave, that is 26 gigahertz, CPE is being ready, and we being able to really use all 10 carriers of 100 megahertz each in a 1000 megahertz chunk, I would be able to reach 10 Gbps throughput on 5G. So from 1 Gbps on midband to 10 Gbps on millimeter wave is what 5G can give you in reality. 6G can give you minimum 100 times of that. 6G can give you 1 Tbps. That's kind of the higher circuit of 6G. It starts from 100 Gbps and it could go up to 1 Tbps. Similarly, in the context of latency, because when you talk about throughput, you got to also speak about latency. So the latency that we really witness in the network today with 5G is 25 millisecond down to 5 millisecond round trip time. Is there a potential for that to go down with 6G? Yes, 1,000 times to 1 microsecond. So I think that is the potential which 6G as a technology is going to offer to all of us. And I work for an Indian company. So I think there's a lot of pride that India has set up an ITU office now. And Indian government has taken a very forward-looking approach towards 5G technology. And more, I see that the percentage of software in 5G and 6G is much more compared to the percentage of the hardware. And with that, surely India is going to have a very natural advantage, which we could explore for many years to come. Until 2030, when we're talking the test beds of 6G to be readied, I think we clearly have an advantage of using our software prowess. But that doesn't mean that we are not ready for hardware. I only expect that our semicon story comes together very well, because that's the only layer of dependence that we have in terms of importing the components, and we are not able to build it up in India yet. So the moment we are ready to do that, I think the entire 6G will be manufactured in India the way the 5G is getting manufactured in India, except the semicon. But going forward until 2030, we would even have the semicon made in India, along with the full 5G gears and the 6G gears. And we would be the suppliers to the world around us. So the last point is AI and ML, which my co-panelist talked about. I think that's going to be really tested to the hilt with 6G. It's already into practice with 5G. And the MEC, which is kind of an NMR today, I think we really need to get past it and put it to practice so that the multi-access edge compute is put to real use, because most of the 6G network, the compute and the storage and even the decision making is going to happen at the edge of the network. So with this short note, I really want to give some time back to you. So thank you very much for inviting me here, Bharat Exhibitions, appreciate it. And now I call upon my co-panelists for their address. So I'm happy to introduce Mr. Satish K to all of you. He is the head of standardization Asia Pacific at Nokia. I'm your ex-colleague, by the way. Please come on the stage. Thank you.
Thanks a lot, Mr. Robert, for that, as I was telling, very presentation. On a lighter note and also a bit of seriousness in that. I mean, you have really left very less for us to speak, but I'll try to do justice of the time that has been given. Actually, you talked about a lot of applications, and if you look at how the different Gs have been developing. So we had 2G, which talked about supporting voice wirelessly, and 3G started introducing data. 4G really took it to scale, and then we started in a very small way to start supporting machine type communication using 4G. Then 5G focus was more on this industrial type of communication. As you see, the number of applications that keep getting added that have to be supported by the network keeps on increasing from one generation to another generation. And with 6G, now that people have tasted the ability for the same network to support multiple applications, things have really been taken to the new level. So you talk about so many different types of applications, but each of these applications have very different requirements. So you essentially need, for supporting, say, these kind of applications, maybe like 20 networks. So it is like supporting 20 generations in one generation. But obviously, as you know, we cannot afford to do that. I mean, we as technology vendors would love to have 20 different varieties so that we can sell more boxes, but that's not economically viable. So we need to create a network or technology that can support these different types of applications in a way that does not It is also efficient in terms of the amount of resources that can be put. As you know, spectrum resources, energy, as well as compute, everything is not infinite. So therefore, there is a need for us to create a system where we can very efficiently manage such a wide variety of applications which require wide variety of configurations. Each application requires a specific configuration for it to work best, and all these things have to coexist. So you would give the task of managing such a complex thing to probably the most brightest species on earth, humans. But as you know, humans cannot do that. So therefore, operators who have to manage such a complex network would look towards machines. Okay, and that's what is the motivation for me to talk about cognitive autonomy and the digital twin, because although when we started in 4G, there was a concept of self-organizing networks. I mean, that was a beginning where we had, algorithms that tried to do the reconfiguration management that would have earlier done in a manual way. But now going ahead with such complexity in the network, relying on AI is not an option at all. I mean, it is an imperative for us. So with that background, I'll slowly move into my presentation. So I'll start with a little bit of definition, because the word, I mean, these terms, autonomy, cognition, like AI, are very well abused, suiting different contexts. So therefore, maybe I'll start with very simple. So autonomy is the ability to act on its own, which is to say that, you know, the network configurations can be changed on their own without human intervention. And when I say cognition, I mean that there is an ability to sense the context, reason out what the context is, and then recommend some future behavior. Okay. And then self-organizing would mean that you can attain steady state, or whatever we call as optimal state, without any external control. Okay. So then I'll come to this point about cognitive autonomous networking. So we would all agree that it is important for us to understand the system concepts and the context in which the different applications are running, so that we can predict if the configuration is optimal for that application to be supported. For example, the configuration in which an IoT device needs to be supported is very different as compared to the context in which a smartphone streaming the video would have to be supported. And if the devices that are supporting IoT communication are subject to a network disturbance, say for example, interference, or say, you know, loss of signal because of some kind of an obstruction coming, the reaction of the network to mitigate that situation would be very different from the way that you would handle a smartphone application. So therefore, to understand the context is one level, which is cognition. Second thing is, depending on the predicted corrective step, the system should be able to take that corrective step on its own, which is automation. Both are essential. So therefore, we say that cognitive autonomous networks are the key for supporting the evolution going beyond 5G and into 6G. We will do some more definitions. Now people talk about digital twin. So I want to start with this illustration where there is a heap of sand. So at what point do you say that grains of sand have become a heap? Or in other words, at what point is a heap just some grains of sand? So similar problem is also there when we talk about the definition of a digital twin. Some people show a dashboard of the network showing the state of different network elements and call it a digital twin. Some people show the map of a physical room like this, for example, chairs, walls, lights, etc., and say that is my digital twin. Some people show a network simulator which actually can predict what would be the traffic patterns if so many devices were put onto the system. So map which represents the physical structure, physical aspects of the network, or for example, this room, plus simulator which has an ability to model the behavior of the actual items in the physical world. Okay, so far so good. So So I will at some point in my talk also talk about why I talk about integration of cognitive autonomy with digital twin, because that has some value to add. And I will do so by sharing a use case. So the journey towards an AI native network, as you rightly pointed out, has already started as part of the 5G journey. So with 5G, early 5G and even 4G, we had the self-organizing networks. With 5G, saw the advent of some proprietary AI/ML solutions. There were some standardized enhancements for network automation where we talked about ability to extract information from the different network elements, what we call as NWDAF, the network data analytic function, and then a mechanism for that to be exposed to the applications. And in this case, it could be the management application, and for them to then do something smart about configuring the network in the optimal way. Then 5G advanced was where we could say that there was a structured way to start putting in technologies inside the network so that you can support AI-based systems to do certain network functions. So the bedrock of AI is collection of data. So how do you collect data? How do you then create models out of the collected data at one network element and then share that across different network elements? Such things started to get introduced as part of the 5G advanced standards, which we call as release 18, 19, and so on. There was also, so since this was the first time when we started introduction of AI into the network, the focus was also on very initial use cases, like the ones that would support load balancing, enhancing energy efficiency of the network. Those were the initial use cases where we thought that we could probably try out AI/ML based techniques and algorithms to do something that is smarter in the network. With 6G, the expectation is that AI and ML functions would be integrated across all the layers. And more importantly, it's not about the network functions being implemented based on AI models, but also how these AI models get created also would be managed by the system itself. So I'll get to that in the next slide. But before that, just also wanted to show that, in 5G Advanced, almost all the components of the network are AI enabled, in the sense that there is work that has already started to support extraction of data, creation of models, and then sharing of models across the system in the 5G Advanced system. Okay, and then, as we say, 5G Advanced is the stepping stone for introduction of AI/ML into the network, as well as stepping stone for 6G. And then finally, we can see how this actually evolves into what we call as cognitive autonomous networks when we get to the 6G state. So as I said, in the 5G Advanced, we have the ability to create the different network functions that would be based on machine learning models. And then the change that you see, I mean, at least one of the changes broadly, is that the whole generation of the models will also be managed by the network itself. So the network management not only manages the network, but it also manages the way these AI models are generated. So all the aspects of transparency, trustworthiness, data privacy, all those aspects will also have to be taken care by the network. Okay, so now back to the digital twin. So we are now more or less on the same page in terms of what is a cognitive autonomous network. A network that has an ability to collect data, understand the context, and then predict future behavior. And then autonomous, because that future action can also be taken without involvement of any external factor, for example, humans. Then what is the digital twin? So when you talk about digital twin, there are two broad categories of the digital twin, since we are a community of people who are involved in the communication network. So from that perspective, there can be two separations that we can make. One digital twin is the digital twin of the system that would use the communication network. Say, for example, a factory consisting of the different machines that are set up, consisting of mobile robots, consisting of walls, consisting of, say, for example, doors, people moving around. So all those entities in the physical world, when they are represented in the virtual world through models where you can visualize animated characters moving, animated robots moving, that would be the digital twin of the physical world, which is going to consume communication network. The second digital twin is the digital twin of the network itself, where we are modeling network elements and then their behavior. So essentially, if you say, what is the big deal about it? The network elements themselves are just software, right? So are we just replicating software from one computer, which is the actual running network, onto my PC and say it is digital twin? That's not the case, because the software, although is similar, but then if you start replicating the complete functionality, then it will become not scalable. So the digital twin of a network would contain again a scoped down version of the network element whose behavior we are most interested in, plus the actual state from the physical network. So now there are two parts here, right? So what we have to see is that these two networks, the physical digital twin plus the network which is there in this building, both of them have to be combined to predict what is the behavior of the physical object. Say, for example, if a robot moves into an area where there are walls, so what would be the kind of radio propagation issues that would be there when you have those walls? And then maybe the designer wants to know, if I replace concrete walls with, say, wooden walls, would there be any improvement? So all those changes can be done as part of the digital twin to understand the impact of physical changes on the communication network, as well as if you want to change then the network topology, what would be the impact on the actual application? So those things can be studied with the digital twin. So now combining digital twin with cognitive automation networks would actually give us an edge, because by definition, digital twin is able to predict what is the impact of physical network topology changes as well as physical device location changes on the kind of network that they experience. So that becomes a feedback loop into the cognitive part of the network management, which can then drive the appropriate automation behavior. So the last part of my my talk here today is to take a use case where we show this thing in action, just to motivate that indeed, I mean, these different domains, when combined together, lead to something that is useful and practical. So the example that I take is a test bed that has been set up between University of Munich and Nokia. So this is Hamburg port. Okay. So the example is of, you know, how we have used a combination of all these concepts to solve a problem in this port area. Okay. So what is this port area? So this port area has got 3 or 4 ships, what they call as barges. And then there are different traffic lights, different, you know, network elements, local applications at the harbor, which can be categorized as EMB. We say, for example, watching the video of the ships, or, you know, controlling the movement of the ships and so on. And then on the ship itself, there are, you know, multiple number of sensors that are available, whose information has to be consumed by the application. Okay. So, and then in terms of data collection, there are, you know, different types of data that you are collecting from the base station, from the UEs, and these have been collected over 6 months, for 6 months, every 5 seconds. Okay. So this is the context in which this particular concept will be applied. So what is the problem here? So IoT requires high reliability. So you cannot lose a sensor which says that temperature was 100 degrees centigrade at one point in time when the optimal temperature is only 75 degrees centigrade, because after that it might actually come to, it might have come to 75, but the fact that one sensor item was missed, which means that you cannot do a critical maintenance operation there. So everybody is convinced that this requires high reliability. Now, what happens is that when the ships are moving across the harbor, there are certain areas where there are some obstructions that come up temporarily or permanently, which would lead to the deterioration of the signal from the network to these sensor devices which are on the ship. And these are long distances. Okay. So, and these could be because the ship has gone long distance from the base station, or because of shadowing effects. Reliable service must be guaranteed even in this case, and it could be done in one of 2 ways. One way is to put 20 times more base stations so that there is no place where the ship is far from the base station, right? So then there would be no problem of radio propagation. But then again, like everything, the network resources cost etc. is also very limited. So therefore, we need to find a way where we optimize the situation in which the reliability for these sensor applications have to be catered to without compromising performance of other applications that are running, which are also equally important, but maybe at that point in time, not that critical to support certain parameters. So with that as the problem statement, we have these slides will be shared with you, so you can actually watch the YouTube video where these things are very beautifully explained. So we have the map of the harbor. If you see this is the real photo and this is the digital twin where the ships move in the digital twin. Okay. So there are two ships that move for each ship in the real world. So if there is one ship in the real world, in the digital twin, two ships move. One which traces the actual ship, the one that is moving in the physical world, plus the one in which you predict what would be the position of the switch of the ship in the next 40 seconds. So therefore, you know in advance, after 40 seconds, what would be the kind of network that this ship would be subjected to, or the sensor devices on that ship would be subjected to. And then according to that, we take corrective action in the network, whether it is increasing the power, changing the tilt of the antenna, so that you can still support reliably the sensor operation. So very simple experimentation, and that actually led us to learn a lot of things in terms of, what is the kind of feedback loops, the latencies that need to be set up, what is the kind of intelligence that we need to put in the digital twin, what is the kind of intelligence in terms of software that is running on the operational network that needs to be put. So this was a very useful experiment that shows how integrating with the physical digital twin, by being able to model the actual movement of the devices on the ground, we are able to make better decisions in terms of network optimization. I mean, getting 40 seconds is like gold in terms of being able to make appropriate configurations in the network. So that thing gets enabled when we have cognitive autonomous network integrated with a digital twin. So essentially, I mean, this also talks about digital twin extended to simulate 5G with beamforming. So you can actually place a physical or virtual base station at different places in the digital twin, and then be able to predict, if you were to place a base station there, what would be the beam strengths available at a position X. So all those things can be done without moving a single screw on the ground. And then another interesting thing is that some of these features, the beam tilt, etc., were not implemented in the physical network, but we could still check the value of these features which were not implemented in the physical network in the virtual world, so that we could save a lot of time in terms of development of the features, as well as the loss of material and time that happens when we have to do it, when we have to do the testing in the physical world. Okay, so with that, I talked about cognitive autonomous networks, which is essentially AI powered network automation. So we see that they are the key enablers for the future networks, because they lead to these two things at a high level: performance improvement of existing network management functions and enabling of new functions. And this leads to simplification of management of these networks for the operator, from focusing on execution of the actual thing to supervision of how things are happening. So the humans can use their intelligence to understand patterns over a longer period of time than to react at 40-second intervals. Then the value addition from integration with digital twin, as illustrated by the project which is called Planar use case, is that replica of the physical test bed enables us to evaluate features that may not yet be present in the actual test bed. Okay, so we talk about strength of India in software, and then hardware also comes with cost. So a lot of experimentation, whether it is with real networks or with universities, can be done by leveraging the fact that now software and AI have improved so much that we can model things very accurately. Separated but chain modeling of the network QoS and the application mobility is another thing that can be done, that is a value add that comes from integration with the digital twin. And then to summarize, so we saw that it's not that the journey started now. It has been there since since LTE. So we had SON. SON has moved to cognitive network management, which we see evolving into cognitive autonomous network, in which the generation of the machine learning model itself can be managed by the network. Okay. So here the key difference is that the management plane takes a new role, managing AI-based functions on the user and the control plane. So with that, I would like to conclude my presentation. Thanks for your time.
Yeah, thank you, Mr. Satish, for your crisp message. You dwelled upon cognitive autonomous network and gave us a digital twin use case from a real life scenario. So thank you very much for that. May I now invite Shri TV Sriram to the forum. TV Sriram is a global lead network operations at Accenture. And his topic today is intelligent network operations, fast track to future ready performance. Welcome, Sriram.
While he's setting up this, I'll use the time to just give you a preview of what I'm going to talk about. So first of all, good afternoon, and I know a lot of people had delicious lunch, and it's very hard, and it's a technical situation, session, and I'm trying to be as interactive and as interesting for you guys. Let me see how much I am successful on it. Okay. So I was listening to the previous speakers in this panel as well as the previous sessions. I think for me, it was a bit of a deja vu, and some of you may relate to this because at least I've been one of the fortunate guys to see the evolution starting from 2G and I think starting from wireline and now going from 2G, and now we're talking about 6G. So these things are interesting, are exciting, and fascinating indeed. And sometimes I feel, am I a part of a science fiction movie here, hosted by Sashidharan and his team? Okay, so nevertheless, what is happening is, while all these technologies are hitting us, both as a user, as a network operator, as a vendor, as a service provider like us, solution providers like us, how much are we adopting? Adoption is not a choice, but how much are we adopting? Right, and I can relate or bring a very mundane example. Nowadays, we have something what we call smart TVs. Right, I don't know whether it will become intelligent TVs going forward, but we go to the showroom, and we normally go to a multi-brand showroom, and we go through and we take the life of that sales guy out. Right, can it do this? Can it do this? Can it prepare coffee? Can it prepare my breakfast? Can it put me to sleep? Whatnot. Right, but at the end of the day, most of us can relate to me. You hardly get time to get hold of the remote. Okay, you end up watching what is being shown, and we just end up there, right? So what I'm trying to say is, while we look at all these features and functionalities of everything when we are doing the evaluation, but are we able to exercise all of that, or adopt all of that, or utilize all of that? Probably that is where the rubber hits the road. Okay. So here in my session, what I've just taken a step back, and I know it's going to be a bit mundane because it is all the dirty work, the heavy lifting which operators do in operations. So please bear with me. It will not be as exciting, but I will try to see how to be prepared for whatever has been spoken earlier, because AI/ML, we are not even scratching the surface in terms of the operational capability which you are utilizing. That's my personal opinion. Okay, and then how we can help clients, operators to get future ready. Okay. So with that, okay. So I think this has been spoken about a lot, but I'm just giving a different perspective. So wireless has grown all the way, and now we are already talking 6G, and it'll keep going forward. Okay, there's no end to that. And the other thing is also on the fixed line. Also, it's also catching up. And somebody, I think, Jeevan was mentioning that they are looking at 5G as the what you call backup link for MPLS, right? So that means probably they are coming into an inflection point in terms of the bandwidth they can deliver reliably. And it has been deployment, and tons of network infrastructure has gone into the field globally. Okay, there are some numbers and there are some sources to it. But on the other side, interestingly, the OEM industry got consolidated, right? So this is the 2-3 things which just keep at the back of your mind. We can't escape without talking about cloud in any forum like this, right? So cloud has been adopted, and one of the reasons which operators were really forced to adopt cloud infrastructure was the pandemic. I don't know how many of you, I've been in this industry for a while now, and during pandemic, 2 industries kept their heads up and actually holding the world together. One of them was the communication industry, and they grew leaps and bounds, and the demand was exponential, unprecedented demand. Okay, I know some of my colleagues in my OEMs who say, look, I'm not going to go and collect my purchase order, let them come and give it to me. Or I'm saying, no, I'm not going to supply this because my factory is full. Okay, I'm going to increase it by another 20% premium. Everything happened, right? So that means the growth has been such that we had to meet the demands of the world, especially during the pandemic, right? And 2 things happened. Cloud adoption happened in a very big way, accelerated way. The other thing which I was observing was the analytics. Data analytics also went into different use cases. I have been working with some of the operators to give them how to actually look at the movement of people or infected people in the network and how we can predict what can happen in the next district or the neighboring districts. So these were all some of the use cases which came and working with the government and with the operators. So unless until we, of course, I'm being an Indian, I'm very respectful Indian, but all of us, we will act only when there is fire under our chair, right? And that's what happened in that pandemic, but it has put a lot of people in different ways of looking at things, right? However, one thing which was very saddening is everybody looked at cloud as only cost takeout. Okay, can I deliver? Can I bring my infrastructure cost down? That was the only driving factor, how to keep my costs low, right? But they missed out lot many things on how we can innovate, what else we can do with this infrastructure. And there's some, paper cuttings or in statements given by different operators, why they want to go into cloud and how it is helping them to do this stuff in a better way. So everything has changed. Traditional networks going towards, I think you know all this, you're all an educated audience here. I'm not going to go through all the things here. It's moving from physical to virtual, right? Too many people, AWS, GCP, Microsoft, everybody's in the play. The value chain is completely getting reconstructed again. So what are those areas? So it's more, I'm looking at from a CSPs, what is the CSP should be doing? Because that is where these technologies are put into operation and they deliver the services. Right, of course, they have to look at completely re-engineering. Of course, a lot of people are doing, some of them are cloud-born operators, some of them are trying to move into the cloud. It's the different operators have different journeys and different challenges along with that. That is one thing, how we can leverage cloud, not just looking at it as a least cost option to deliver a service. The second thing, of course, is how do you optimize network operations, especially leveraging all the technologies we have, AI and ML, right? And the third thing is you have to offer new products and services. There is a big mindset. It's again, I've been in an operator myself for close to more than 10 years. It's still some of the, when I have the discussion, the mindset is pretty much a connectivity oriented mindset, right? Okay, as long as I'm connecting, I'm fine. And let us not bother about the rest of the things. But there are a lot of people who are trying to do something in terms of applications and bringing platforms, all those things. But predominantly, I'm talking about majority of the operators globally. It's not just here. Globally, they are saying, okay, I'm a good connectivity provider. I need to figure out. So there are opportunities on how to bridge that gap as well. But my focus is going to be pretty much on operations today. And so if you're putting these investments in these areas, a desired output all of us or all the operators want is to how to improve revenue or jack up revenue. Because what happened during the pandemic, the exponential demand went up, along with the cost of deployment also went up. The revenue didn't go up in the same sort of slope. So there is always a cost to serve and a revenue. So the profitability got into a big sort of a challenge, right? How do you drive that? And of course, ARPU is all operators are measured on this. Also, if you have put your network to so much of strain and hard work, my strong feeling, or it has been, is unless until your employees are satisfied and happy, you will not have happy customers. Because the employees who went through this pandemic growth and the way they responded to that sort of a thing, for any operator has been unbelievable, incredible. Because I've heard a lot of stories, a lot of my friends and colleagues are working in this space. So it is unimaginable what they went through, okay? And during this pandemic, why I'm saying pandemic, because that actually pivoted a lot of things in this industry, okay? So a lot of people went, they made their, what I call the showroom, okay? Very, very jazzy, okay? Omni-channel, I should not leave the customer. He should be able to reach me at any point of time. So a lot of front office transformation happened. A lot of money was spent. Okay, they can call, they can SMS, they can do whatever, and they'll be able to land. Similarly, on the back office, cloud, okay, moving to cloud or disaggregated was different ways of putting all the things in place. But there is a huge chunk of talent which needs to be upgraded, which is sitting in the middle office, which is operations, right? That has not been jacked up or modernized to the level at which it can support both the front office and the back office. Okay, and most of the time operations has been looked at just people or technology, because most of the clients or customers whom I talk to, oh, we have got the best tools under the sun in our network. Okay, fine. What do you do with those tools? Right? And if you go and tell them, okay, tell me, how do you measure this, or how do you actually, are you able to get this visibility in this space? There are a lot of things. This is one. Second thing is, a lot of operators also build data lakes, right? Data lakes, everybody built that data lake. And all of them did was grounds up data. Okay, I will collect everything in my network, put all the probes in place, put everything. And I'm a bit, was thinking when Satish was mentioning, there'll be a lot of AI, ML intelligence, a lot of data is going to come. There is already tons of data which you are not able to handle and which you are not able to make sense of, and how do you put it into smart decision making, right? So it's going to be more and more of that, and that's where probably I think it's a bit more sort of segue into what I'm going to talk about. Okay, I think I've spoken about this. Moving from cost mindset to innovation mindset is very key. And it also needs to be done in operations. It's not just a marketing or a product development sort of a agenda, but it has to go across. So there should be a big technology business interconnect for any organization to achieve this thing. And that is a cultural alignment which the organization, it's not easy. Believe me, I've been in this and trying to do certain things like this. It is not easy to get a few people together on this sort of a mindset. Okay. And I think some of the points Satish also mentioned, if you have to give good service, overbook the bandwidth, or overbook or over-engineer your network for unlimited capacity, right? And we have seen this in Backbone, we have seen this in a lot many other places, in Access, wherever, but that is not going to be any more feasible in terms of commercial, as well as in terms of making sense of, you can't just deliver service by just jacking up your capacity. So from there, you have to look at customer and employee experience more, which can help you in this. So it is going to be a shakeup from status quo to how to become future ready, because 6G, AML, what can, digital twins, all of them are going to hit you, not very late, but very, very soon. Okay, so it's like Synops is a sort of a platform which combines the capability of the human and machine intelligence. It's a cloud-enabled platform. And we have been working with a lot of clients across industries. So when I talk about operations, while it is all about network operations, but this particular platform we have been able to deploy across industries to support their operations and leapfrog the maturity levels. I'll talk about the maturity levels in a second. So what it does is diverse data. So network in the early stages used to be just billing data. That was the only data which we all know, right? Then after that, lot many things happened. Then billing data, then you call, transactions started happening. Then you have customer data. Then you have now crowdsourced data. Now you have social engineering feeds, whatnot, right? So there is a diverse set of sources of data, right? How do we actually look at the right combination to make some sense out of it and drive a decision making? From this data, make some sense. Data is just information. Okay, it can throw any, it's like a, what do you call, I'll call diarrhea. Okay, so it keeps coming from any nook and corner of your network, right? So how do you handle it? Okay, so based on that, you have to make some sense out of it, drive some intelligence, and see how is it you can do your decision making, whether it can be closed loop automation, or it can be shutting down a few things, or can be, okay, this product is not giving me sort of profitability which I would like to have, so I'll shut down this and do something else. So it can be anything. And of course, how do you drive experiences? This is also an important piece because operations, as I told you, has always been looked at. We had the technology, oh, we have the best people in town. Okay, so what? Right? Because today, for example, if I have to take an instance, you're not fighting people on the other side. A security sort of a threat or a security, it's done by bots. Okay, you're fighting a machine. You can't fight a machine with manual. Of course, human intelligence is unlimited, but human capacity is limited in terms of time, in terms of the response you need to give, right? So how can you look at hyper automation to do all your regular mundane stuff, voluminous stuff, non-complex stuff, so that you free up human intelligence for doing the creative work? So that is the other aspect of this Synops framework. And also, if you are able to give that headwind or headroom or bandwidth to your most creative and expert people, then it's easy for you to do a lot many things with it. All these things have to be put across a work orchestration, right? We don't want to do everything and then finally somebody gives a command or logs into something and say, okay, I will give this command. That's not what it is. How do you actually implement or integrate it into your work orchestration? And it can be network service fulfillment, it can be service assurance, it can be customer operations, it can be billing operations, anything. Okay, this entire range, how do you actually drive all these things? And last but not the least, I'm not going to do this just for the heck of, because I have a technology and I have some set of people who are cool in doing this. I want to drive business outcomes, right? Whether it is NPS, whether it is profitability, whether it is efficiency, or whether it is going to be your employee experience, right? So with this, we were able to move a few things from transactional, because you can't look at it as a very transactional thing, right? Okay, I've been doing this for so many years. I will add 2 more things and I will do. It's a very, very incremental approach, which will not take you to where you want to be. Okay, you need to look at it from a long-term perspective in a very disruptive way, because as we heard the previous speakers, there is a lot more going to hit you. If you don't know how to drive a manual car efficiently, forget about doing it with an EV or something else, or maybe autonomous. Autonomous, of course, we don't need to drive, but we will have to sit inside, right? So based on our experience and research which Accenture conducted across, the research was conducted about a couple of years, so just when we were coming out of the pandemic, across about 1,000 plus CXOs, cross industry and cross functions, of which about 50 communication service providers were also included. Okay, so based on that, we found that there are 4 levels of operational maturity. The stable one, which is like the standard one, which everything is there. You have a framework, you have some compliances happening, you have some processes defined and all that stuff. That is a very basic stage. Then you go to the efficient, which is like a bit more automated. You are running RPAs, robotic process automation, and the mundane stuff, which is something about the Lean Six Sigma and about business excellence and all that stuff. The third piece is a predictive, where you have started using data and to drive a bit more of predictability into the, okay, what will happen, what if scenarios you build, and see what is it you can do. Okay, and the last is what we call the future ready set, where actually you are driving efficiency and profitability and driving business outcomes. The predictive mode is still about very operational and transactional. Okay, when I talk about future ready, this is more about how do you improve the stakeholder experience across board. So based on that, what we observed was CSPs or communication service providers, traditionally they are good in technology because it's a technology intensive industry, right? So automation, they were very much higher than the industry average. So that is a very good platform to be in or a very good position to be in. But are they leveraging that capability or strength to deliver some of the few things? Probably not. Like I said, it's all very much operational. Okay, can I reduce this? Can I address the cost? Can I be a bit more this? That's about it. And future ready organizations, what we thought about 7% in that sample size. Only 7% was there. Okay. So from a comms perspective, 70% were there in predictive area. That is the stage of the maturity level. But moving from predictive to future ready, it is actually a chasm you have to jump, right? That is why no incremental approaches will take you there. You need to really be a bit more disruptive there. So how do we do and what do we do? Before that, each and every level, as the thing says, we used to talk about just technologies or people or process. But this, we had put a fourth dimension to it, which is the data piece and the data insights, not just data. So if you look at this, these 4 dimensions give you a good, more holistic view of how you can drive your operations to the future ready mode. So what does it mean? Just this, if you want to take key takeaway of this presentation is just this. Okay, so I would request, I know some people are tired, but I would request to just give me 5 minutes to go through these 4 slides. What do we mean by foundation? As I told you, stable mode of operations, everything is there. You have a benchmarking process. You have, all I want you to do is, I don't know if this works. Okay, I hope it's there. So look at the talent, how this transformation is happening on the talent side and how it is happening on the workforce distribution side and how it is happening on the top quartile and the optimized operations in terms of what sort of impact areas we are looking at. Okay, if you're in the base foundation mode, everything is there. You have the right shoring option because I'm talking about operations, so it's cross board. We do a lot of offshoring and onshoring and right shoring and all that stuff. SQF, KPI, everything is there. SLAs, everything is there. But you're still focusing on just efficiency, experience, quality, and compliance. That is your quartile benchmarking on the right-hand side, the bar chart. And if you see on the spider diagram, you're looking at just SLA and maybe some productivity. That's about it. Okay, from there, if you move to the next efficient way of automation, human and machine combination improves. So you've started putting more automation in place. But if you look at the talent, you have technology experts, your SMEs or SMEs, as you call them. You need also business advisors. So you need a team which understands, if you do this, what is the impact from a business perspective? Okay, what sort of a business outcome can I drive? And on the right-hand side, if you see the tooling, all those things happen, RPA, the process maturity model, all that, right? Troubleshooting, enable all the frameworks, all these things are available there. And on the optimized operations side, if you see, you're slightly moving towards predictive operations. The triangle is becoming some sort of a hexagon, maybe. Yeah. And you're able to drive about higher productive real-time insights you started using. Business outcomes, touchless or zero touch is still minimal there. Go to the next level, insights driven or predictive. You have completely moved from, say, the first phase, you are highly transactional, a bit more automated in the second phase. The third phase, your agility comes in terms of data scientists, AI experts, all these people following. And if you see the optimized operation, that spider diagram is also a bit more wider in terms of addressing all those 4 dimensions. And you are slowly started getting some business outcomes in place. The last but not the least is here, and this is where 70% of the operators are today based on the survey we have conducted or the research we have conducted. Okay. And from here to jump here, it's as I told you, it's a chasm. It's not easy. You can't just do a few things and go there. But if you see this, your talent mix is completely different. The way you are looking at the optimized operations in terms of future readiness, real-time insights, high productive, you can define all these things for yourself. Okay, I'm just giving you some generic terminologies here. But the top quartile benchmarking, if you see, you are able to address everything. So efficiency, experience, quality, compliance, human-machine combination, business outcome, and touchless or zero-touch operations. So this is something which we have been engaging with different clients across industries and helping them to improve. This is powered by Synops. Okay, that is a platform which I was earlier describing to you. So does it stop there? How do we do this? Okay, so we look at value as in 360 degrees. Okay, it's not just financial. Okay, we are looking at financial is of course there, CapEx, OpEx, that is the base minimum business case you have to develop even when you go for any engagements. But beyond that, we are looking at experience, not just the client, but also the employee as well as the partner, because it's going to be a highly partner ecosystem driven models going forward, right? So each and everybody has to work towards the value you want to deliver. So partner experience is also equally important. Sustainability, of course, we have, and all whatever I'm saying is not theory, it's not a presentation. We have projects which are being measured like this today, and we'll be happy to share more information as and when required. So if you see sustainability, like everybody was talking about energy, a lot of things, these things will consume a lot of energy as we move forward, right? So how are you going to be, every corporate has got their own sustainability goals in terms of carbon credits and being carbon neutral by so-and-so date, right? All those things gets plugged in into this particular framework. Talent, of course, how do you develop talent, reskill, upskill, and also how do you do change? How do you manage attrition, right? Inclusion and diversity across board. Again, pandemic gave us a lot of lessons in inclusion and diversity, how the workforce can be completely different, where you can't even think of from where these people are coming from. And apart from that, the customer has got I want, apart from this, these are the 2-3 things which I want to drive. Custom also is available. You can plug it there. Okay, and this gets actually measured and governed in a tracking mechanism, all completely online on this framework, right? So we call this, and we measure our contracts also TVE, or total value enabled for the client. And there is a internal meet or dashboard which keeps represented. This client, we have delivered so much of value over the period of so much across industries, across function, and across clients. So how do we reach there? I think most of the things I've touched upon, just to summarize on this, you should know what you are going to achieve or what you want to achieve. Okay. So if you are clear about that, okay, when I say think big with strategy, you don't need to hire some consultants and do something. You say, look, my business is here. I want to bring this business to here at some state, right? Have that as a customer focused or as a business focused sort of an approach. From there, you can take, if you're saying, okay, today I'm operating at, I'll tell you the traditional way. I have 500 people in my NOC. If I bring them to 300, I'm good. That is a very transactional incremental approach. Okay, so you have to see, okay, if I bring 200, what am I going to deliver in terms of customer experience? What am I going to deliver? Am I going to add to the bottom line of the company? These are different things which needs to be think, and this can be tied back to what it is. And of course, business technology interlock is very, very critical. I don't know how many of you, some of you would have done the DevOps and the different ways in which you drive operations or projects, even in system integration. You all something called user stories or customer journeys. All these things are now new things which have come up being in an agile workforce. You can't do this sitting alone in your technical war room. You have to bring business people in, and they have to tell you whether it makes sense or not, whether it is assurance, whether it is fulfillment, whether it is new product development, whether it is new market, technology, business. When I say technology, I use both networks and IT. Technology is common, ICT. right? So don't get me, okay, what about IT? What about network? I'm talking about all technology because there is no function which is technology averse. Everything is very, very pervasive now. So do that. That is also going to be so that you'll be able to figure out what exactly will help them. So the organization or the team comes on ground to this. The second thing is know the key steps. Okay, if you have automated to some extent, what is the sort of hyper automation you can look at, and how can you free human creativity from that, right? So here again, a lot of people have done a lot of attempts in terms of making sense out of the data, but you have to accelerate it a bit more because there is going to be more and more data being sent to you, and you need to look at how do you do this. The third important thing is a lot of operators are in different stage, okay? And the 3 to 4, the predictive to future ready actually has to be a leapfrog. You can't walk across or you have to actually jump because it's a chasm, we need to jump, right? So there it needs to be a lot of mindset, and change is going to be very key there. And the alignment and the appetite of the organization for change is also very important. So it's more of that, and you can only do as an operator, as an OEM, only so much. So build your strong ecosystem for partners, and that we saw again. Now, no operator will say everybody has got Microsoft or GCP or AWS in their ecosystem. Oracle, you call them, like there is a different bunch of operators or different players in the ecosystem. So what do we get? And whatever I'm saying, as I told you, these are all based on research and proven metrics, right? It's not that this is a desirable output we want to have. This is something what we said, okay, if these are the future ready organizations, as I told you, 7% of them are there. And so it's about 1.7x or double 2x efficiency improvement. When I say efficiency, you can define it in different ways. The basic simple way is cost to serve. Okay, for the same dollar of revenue, I'm able to reduce my cost by 2x, right? And of course, the profitability because of it, which actually moves your bottom line also up. So these are the hard, tangible benefits from a business or a number perspective. But at the same time, as we saw in those 4 transitions from maturity levels, your talent mix is much more improved. You're able to reskill your talent, make them future ready, and both your customer experience and your employee experience goes up. And of course, your ecosystem relationship also matures. So the choice is there. And while, as I told you, the majority of the CSPs based on their technology excellence are already in predictive stage, but they have to do more and fast because 5G, everybody is looking at it in a deployment mode. That's how it is. But at the same time, you need to bring the middle office also equally up so that you don't need to worry about how the operations are running. Will it be able to cater to my increased demand or increased technology stuff? So you can focus on your business and customers, which is more where you should be rather than looking at technology is available to everybody and anybody can do anything, right? So try this across these 3 dimensions of people, process, technology, and of course, data insights. So that's probably brings an end to my thing. Thanks a lot for your patience. Appreciate it.
Hello. Yeah. Sorry. So thank you, Sriram. Your presentation is a reality check. So that's the right word to use for your presentation. And moreover, I think there is an author called James Clear. He wrote a book, Atomic Habits. So he suggests that if we bring a small positive change in our life and do it on a continual basis without losing our momentum, then collectively it brings a very sea change in our life over a period. So I think that's what he's trying to allude to. So thank you very much. Now the panel is open to take questions from audience. So if you have any question, please feel free to address it to one of us. Yes, please. There is a question there.
Paul Dayanudhi. I'm Paul Dayanudhi. My question to CTO, his name is Robert. You were telling NOMA is already implemented, is planning to be implemented in 6G. Are you sure about it? In your lecture, you were telling that NOMA, non-orthogonal multiple access.
Yeah,
Because
one model of this is already in for 5G is being evaluated.
But
It's
as
going to be
per-
the next level of it is going to go in 6G.
But in 6G, it is already standardized that OFTS will be the modulation. The OFTS is a modulation technique. Are you aware of it?
Sure. Sorry for if I may take that. So 6G, nothing has been standardized yet, but like that indicated.
Because the Doppler effect delay is minimized. Intersymbol interference is minimized with the Doppler delayed interference. That is being minimized in OFTS. That is why I was wondering how NOMA is coming into picture.
Yeah,
Because
so-
NOMA is a I have submitted an IEEE paper on that. That's what I'm asking this question.
No, you are right, but all I'm trying to say is that nothing has been decided or standardized yet. So different types of waveforms are appropriate for different types of scenarios and applications. And for places where Doppler is an issue, probably OTFS, like you're telling, is more appropriate.
Will intelligent reflecting surface antenna will be the optimum solution for a 6G?
That also
No.
is not cast in stone. I mean, there are different studies which indicate how much percentage gains that you get from it, but it is certainly a very promising technology that needs to be evaluated. But
Now let us put very, very clearly, whatever the technologies you have mentioned is all evolving. No standardization has been done, but as I mentioned, in 2020, the IT working group put a roadmap of what should be the network by 2030. So this is the applications that we want. That has been decided. So of course there are different, as I told you, not only NOMA, we even talk about spatial division multiplexing also. So the technology, what is going to evolve, a lot of research is going on every area. As he told, RIS is one of the key area, the reflective intelligent surfaces, not only the small sub, even the large intelligent surfaces. These are a lot of research is going on in a number of countries on this particular one. They are trying to bring in, as I mentioned during my speak, even as a paint, is not going to be a real device. RIS is not going to be a device such it could be even take a form of a paint also. There's a lot of research is going on, but that is the one field where people are looking at because of the simple reason I told you, N and K. When you want to have N APs connected to K users, N greater than K, then your reflecting surfaces should be automatically done. That's obviously one of the choices which people are looking at.
Thank you. Is there any other question?
Yes, sir. I'm Dr. Jagdish Shivare, professor and ex-scientist ISRO. Sir, my question, we are expecting 6G by 2030 in our country. But my friends in Norway say they are using 7G and 8G and 10G in Japan. So if it is true, why we are not working on 10G instead of 6G?
No, sorry. I would like to take it from an industry perspective. I may not have a very good answer for you from a technology standpoint. Sandeep, you may have, and you can contribute if you do have. But these are all test beds. So they are very, very algorithmic models that the people must be working on. But when it comes to the real rollout, nobody has rolled out anything beyond 5G. So 5G is something which is commercially been deployed and being exploited, and 6G testbeds are ready. However, to bring it to a commercial size, it will take minimum 5-6 years. So that's where we stand as an industry today. I don't know, with any of the panelists, you want to add anything? No, give it to him. Yeah, sure. Sure. No. Give it to Sandeep. He wants to add something.
Hello. First of all, just to address your question, when we talk about G is always related to the degree of standardization. So till now, only 5G is standardized, 6G is going to come. So whatever G that you're talking about, that might be a generation of some other technology, not the wireless. The 10G, 7G. So when you say internet speeds, that are the speeds maybe from the fiber and other things. This G that we are talking today is about the wireless technology generations. So G is the generation that can be, even if you look at the Honda scooters, they are launching 6G, but that doesn't mean that a wireless 6G. That is 6th generation of Honda scooters. Just to answer your question. Yeah, this is not wireless.
Okay, thank you. I think it's a very good way to conclude it while all of us are laughing. So thank you very much.
One more, last question.
Okay. There's one more question.
Yes.
Yes, please.
In terms of affordability, normally whenever I'm a chartered accountant, so I would put it from the financial point of view. Whenever we are launching a product, there's a market survey. We go to the customer, we understand his requirement, we understand his pocket, and then we try to do the backward working to get the financials right. I think that's a prudent way of doing it. Now in this, probably I think even for 4G, the revenue which we are getting, the ARPU of 180 rupees, is not sufficient to make it into, to make it viable. So what would be the ARPU or government support you'll require so that it's a viable thing? It doesn't go into, it doesn't become a bad project where, public money is being, is the ultimate funder of the whole project. So what would be the government subsidy support you'll require where government comes in as a financer to put in the money for the beneficiaries? So the beneficiary is paying almost 180 rupees per month as an ARPU. So I think that's a pertinent thing.
Yeah, so coming from the telecom fraternity, possibly I can pick it up. However, this is the nature of this industry, right? I mean, the licenses are sought for almost 15 years, and then the money's been paid to the government. Initially, it was upfront, and then it was monetized over a period of 15 years. Erstwhile, say 20 years now, the term has come down. But nonetheless, that is the nature of this industry. It's capital intensive. And that's where you see there are very limited players who are in the fray. Moreover, all the new technologies are not necessarily expensive. The new technologies are very efficient. So the spectral efficiency of those technology is doing a lot of justice to the price resource, which is the spectrum. So I'm able to do a lot more megabits of the data now in the given chunk of a spectrum compared to what I was doing in the previous generations of the technology. So similarly, with the new 6G coming in, I would actually be able to pump in more data in the given chunk. So I think that way we are already monetizing more. And why a new technology? That's a question which I sensed in the room as well. So I think the answer truly lies in our own behavior. When I drive my car, a few years back, I used to download an MP3 app and listen to the songs. Now what I do? We all turn on YouTube, it is running, and then we are driving car. So we're just listening to the music, and for which we're consuming a lot of data unintendedly on the network, I mean, without even watching it. So that's the behavioral change. I think it is driving the new technology and the consumption on the network. It's many a times not purposeful, but it's happening. And with the 5G launch, within few months, since October 2022, we had seen that the data had gone up 40% on the network. So, and the tariff you see is the plan for 4G and 5G is same. However, the data has gone up, and hence the ARPU has gone up for 5G users because you're paying for the extra data that you're doing on the network. So your behavior is driving all of this, and plus the new technology as well. I don't know if you want to add.
Okay, it's on.
Yeah, it's on.
So I just have one more perspective to it. I don't know, probably you said you're a CA or financial guy. Okay, so the government SOPs can help you only in delaying your cost investment, delaying your cost still as an operator, as a service provider, you have to look at how do you monetize your technology, right? Because like 5G is a fat 4G as of now, like what Jeevan also was corroborating this. So how do you actually monetize 5G? That is going to be a thing. And for us, India is in an interesting situation because as I told you, I've seen this 2G transformation coming wherever we are today. And I don't know how many of you realized we completely leapfrogged 3G. We didn't go into 3G big time. Okay, but we did some investments, but we leapfrogged from, when I say 3G, we didn't go to the UMTS one, we went directly to HSDPA, which is like 3.5 or 3.75, whatever they call it, right? So like that, there are some advantages for being late starters. But for your question, my perspective, my view, don't take this as Accenture code. This is my personal opinion. Okay, government subs, because why I'm saying this is government subs have been given in Europe, and they have given, like, for example, I don't know if it is like 25 euros a month or something. That is the sort of fee they have to pay for the spectrum, and people can go and launch private networks, right? So that is one way of looking at it. But all these things are not sustainable, in my opinion. Government shops will only take you, maybe they can give you a spectrum, I'm just thinking aloud, maybe they can give you a spectrum holiday for a few years, but that will only address your cost part of it. But still you have to figure out what is it you're going to use the technology for monetizing it. I think that's where the crux is.
Yeah, just to add a couple of things. First, from the government side, you already know, we have already brought up the 6G mission. We are going to support the right sphere, maybe in the R&D or the particular type. Yes, government support will be there. Please don't expect it on the subsidy side or anything. That's going to be the later. You need to think when the new technology rightly comes, it not necessarily be expensive, as you rightly pointed out. The entire business model will go for a toss in 6G. Mark my word. The entire business model will go for a toss in 6G because the network itself, if you see, I was mentioning a lot of networks. We are going into second network. We are the information technology. So the entire stuff is completely changing. So as you rightly made, you mentioned about captive non-public networks growth is coming up. These captive non-public network means you and the citizens himself going to be a partner and thing. The operators are going to be the, the wholesale agent, and the retail agents are going to be you and me like citizens. So that is another model that is evolving everywhere. So 6G definitely is going to be, as I rightly told, if RIS really becomes a plane, you're just going to do a specialized paint in your walls and then have a RIS controller. You yourself are going to take a revenue out of it. So the business model will completely go for a toss. Everything is going to change. So don't compare with 5G to 4G because, you know, even the cellular concept has gone for a toss in 6G. So why not a business model go for a toss?
Thank you, sir. We come to the end of the first day of 6G India tomorrow. 6G, maybe during the tea time. 6G India 2023, the first conference on 6G. May I request our special address, Sri Robert Ravi, to present the memento to the distinguished speakers. First to the chair, Jeevan Pelgaonkar, the Vice President and Head of 5G Solutions, Reliance Jio. To Satish. To Sriram. Both come from the same country. And may I request Jeevan to present a memento to the Sri Robert Ravi. Thank you, ladies and gentlemen. We'll have a tea break and then see you tomorrow sharp at 9:45. See you. Thank you very much. Good one.